keep messing with this now that I got the hang of this thing. Virgin is about to take off. Yeah, I've been told that. He got mad when I gifted Max a sub to his channel. Alright. Let's save it. Just double check. Double check I got the save. Alright. Alright, let's I'm gonna switch this over to Space News. Or we could just do coverage. We could just do launch coverage. That's... Oh, I just freaking... Okay, let's just chill. Let's not make any crazy decisions, okay? I kind of want to mess with that a little bit more. Maybe on the other side of my summer car. We'll do that. Where is that Virgin orbit mission? Above the clouds. Here we go. We're just in time. I hate the freaking round pods. Every time my rocket flips when I use one. Oh, here it goes. This is Mojave, I think. Yeah, she's kind of hanging on one side, eh, Jim? Look at that thing. Look at that. That 747 has a rocket on it. Oh! Bro! That's awesome. Positive rate. Gear up. Yeah, I see it, S. Yeah, look at the aileron. Yeah, that aileron is trimmed down like crazy. That 747 has a rocket attached to it. Just thought I'd let you know. Yeah, you should be able to follow on FlightAware. Man, this brings new credence to the term mobile launch pad. Look at that. I hope so, Admana. Jeez. Yeah, Sebby, that'd be pretty cool. That's wild. So we're still... Oh, man.
And there you have a successful takeoff of Cosmic Girl and Launcher 1 from the runway at the Mojave Air and Spaceport in Mojave, California. Looks like Cosmic Girl is on her way to going above the clouds.
I know. That was an absolutely gorgeous view of Cosmic Girl as she was taking off with the Eastern Sierras in the background. A fun fact about the design for the rocket, one of the things we had to consider from an aerodynamic standpoint was making sure that the rocket didn't have too large of tail fins so they wouldn't strike the tarmac as Cosmic Girl was taking off. So we had to do a little design right there to get it just right.
And as a reminder, Cosmic Girl will be flying out to the Pacific Ocean to the drop point, which is about 50 miles south of the Channel Islands.
It's gonna take a second to get out to sea here. It's gotta fly out over, cause this is Mojave. It's gotta fly over the mountain range, the high desert. we have an onboard shot from the plane? Tell me we do. What mile long said goalie? Yeah, Core, I saw it. It was linked yesterday. I forgot to cover it for Space News, but yeah, the GSE working is pretty cool. That umbilical snapping, the umbilical going in, and it's the TSM snapping shut, which is really cool. This is live, Nucleotron. Yeah, the plane just took off. It has the rocket underslung on the left wing. Yeah, Falcon, I kind of wish they would show us some onboards right now. That would be really cool, but hey, it is what it is. Two more possible future rocket launchers in the background here. Yeah. I wish. It's a great shot from Jack. I don't know, Sirius, maybe. Oh, there she is. Look under the, if you look under this wing right here, you see the rocket's underneath that. So, thank you. There's the rocket on the pylon. So, Virgin Orbit is different than Virgin Galactic. What Virgin Orbit does is they're a small sat launcher that uses their Launcher 1 vehicle. Launcher 1 is a strato-launched rocket. So instead of launching the rocket like on a pad, right? They launch it off of that, the 747. It's underslung under the wing. And the 747 will go into a huge nose up when they're ready to launch. It'll go into a huge nose up, and then it'll let the rocket go, and it'll shoot it off into space. It's a is it 3-stage? I think it's 2-stage. Yeah, 2-stage. There's second stage engine cutoff there. So it's a 2-stage to orbit vehicle after being launched off of the 747. It's actually really freaking cool. This looks like it's a camera that's looking at the attachment pylon. That's what the red thing is. The red thing is the cradle that holds the rocket on the wing. Two-stage with 3 if you include the 747. Yep. No. Jesus. It's terrible.
Discovery, go at throttle up.
Hey, Quark, 32-month resub. Sun Temple, the 747 is going to go up like this, let the rocket go, and then the 747 will peel off and do a turn away from the vehicle and let the rocket go. It'll kind of fling it up in the air. Kind of like how they dropped the atomic bombs, except this is not going to hurt anyone. It's designed to just go up into space, not turn like 300,000 people into glass. Yeah. So it's gonna like the 747 will go up and it'll turn and it'll let it go, and it kind of lobs the rocket on a suborbital trajectory, and then they light it and then it goes. This camera is on the back of the rocket looking forward, I think, if I'm looking at the wing configuration correctly there. Hello.
Hi.
How are you?
I'm okay.
Did you get chicken?
I got chicken.
Okay.
I can't feel my mouth.
Why? Oh, you gotta get dentist appointment?
Yeah, I got the dentist appointment.
They might have a dentist appointment, can't feel your mouth.
And now joining us is
Hey.
a very special guest, the founder of the Virgin Group, the man, the myth, the legend himself, Sir Richard Branson.
Oh, Richard!
Nice to talk to you.
Nice seeing you today, Richard. So you were in Mojave for our last
Wait,
launch, Tubular Bells Part 1. How are you feeling after just watching Cosmic Girl take off?
But
Obviously, just like all of you, excited,
Richard
always slightly
Branson.
nervous at this stage. You can
Chat
never
says hi, by the way.
be sure in these early flights whether every mission is going to be successful. But you know, just at the edge of my seat, like you and the rest of them, and it's incredible what the whole team have accomplished. I can't remember whether this is our third flight or fourth flight, but anyway, it's always incredible to be watching, and a great privilege.
Now, Sir Richard, the beauty of flexible small launch is that we can service a diverse array of customers on the same flight. On this one, we have U.S. government, U.S. commercial, and international customer payloads. What do you find most exciting about that?
Oh, look, I think that for people who question space exploration, they don't realize just how much it offers to mankind back here on Earth. I mean, one of our satellites that is going up today will be monitoring agriculture and crops around the world and so on. And it is that wonderful diversity.
They are frilled, yeah.
Of different organizations and different companies that have got brilliant ideas to try
that's
to
not the question,
use
but all
space to better things back here on Earth. And I think we've
be nice,
got
Sebby.
something like 20 other customers waiting in the wings after this to put
in the wings.
to put their projects up, and I'm sure there'll be many more after that.
Absolutely.
So let's talk about the future of Virgin Orbit, actually. I know we have a number of launches coming up. Which one are you most excited about?
I mean, I think that I was just looking at the 747 and having a little bit of a trip down memory lane. And this plane was I think the second plane into Virgin Atlantic's fleet, something like 38 years ago. I wasn't sure that Virgin Atlantic would survive more than a year or two, and I don't think anybody were in those days. We were taking on, British Airways with 300 planes, and we had a couple of planes. I certainly was not sure that, or never dreamt that one day it would be taking off from Mojave with a giant rocket on its side,
Fellas, didn't the 747-400 roll out in the early 90s? He said the plane was 38 years old. That's a Dash 4, right? Cosmic Girl?
So it's definitely
Are you sure, Jam?
a pinch me moment.
No,
I mean,
it can't be a Dash
this
2.
goes
The
right back
fuselage
to
is
when I one day saw one of our 747s taking off with three.
It was made in 2001. Okay. All right, cool. 22 minus 21 is 38. Yeah, okay, cool. Got it.
Maybe we could put a rocket on it. The reason for three engines on one side and two engines on the other was, if there's a technical problem in Alaska, you have to send one of your other 747s to bring
Yeah, the
a
deadhead
spare
mount.
engine.
This
The
is
only way
cool.
you're going to
He's
get
right.
it there is to put it on the wing. As to the future, I mean, I'm obviously excited about every
More money
single
towards
rocket
Space
launch
Geek.
and all the different things that
But yeah.
all the satellites inside those rockets can do. I mean,
Why,
there are so many urgent things that need doing back here on Earth. Where, whether it's monitoring the rainforests, maybe places like Norway who are doing deals with places like Brazil to ask them to not to cut down the rainforests, and then rewarding countries for for not cutting down rainforests. The only way you can properly check on it is really via satellite. I mean, you can do a certain amount on the ground, but to completely verify it on a month-by-month basis, you need to do it from the air. So it's projects like that. I mean, in the Virgin Islands, right here, we have illegal, fishing boats coming through. Again, it needs satellites to be able to alert the authorities that trawlers are coming through with massive nets and long lines and pillaging the seas that belong to the British Virgin Islanders. And that's the kind of role that Virgin Orbit can play. And Virgin Orbit is unique in the world. I mean, the fact that we can actually, there's only, I think, a couple of handfuls of countries that have the capability of sending
Yeah, I'm just listening.
satellites to space from their own countries. And now all 180 countries can use Virgin Orbit. They just need to ring us up. We can send a 747 and operate out of their own country and launch satellites for the first time. The UK is one good example. I mean, later this year, we should be launching from Cornwall.
All right, fellas. Okay, so here, Virgin Orbit has a really, really unique capability. What the capability is one, well, their launch pad moves around. Their launch pad is the 747-400. This is Cosmic Girl. It was a Virgin Airlines airplane, and it was converted in 2015. They modified the fifth pylon mount on the left side of the 747 to be able to launch the rocket with a special adapter. Now, what do I mean the fifth pylon mount? Well, pylons are the airplane way of saying engine mounts, right? See, each one of these engines is mounted on a pylon, right? A lot of people don't know the 747 has 5 pylons on it. Richard was talking about that a second ago. It has 5 pylons on it because in case it needs to deadhead an engine. Now, why would a 747 need to carry 5 engines? That doesn't make any sense. Well, if a 747 flew to a far-off destination and it had engine problems and there was no engines on hand, right? Like if it flew to a remote island or something, right? And there was no engines on hand and there was no facilities to do the right maintenance or that would have an engine on hand, the next 747 that you send out there can carry the engine. And it'll land with 5 engines. They'll take the engine off, replace the broken one on the 747 with a broken engine, and then take the junk engine, attach it to that 5th pylon, and they send it back. You could basically deadhead engines back and forth. So the 747 has 5 engine mounts. So it was actually kind of a no-brainer taking that 5th pylon and converting it to a rocket launcher. There's a two-stage rocket attached to the 747. So when he says that they can fly anywhere, they can fly anywhere. Now, the integration equipment, the crazy thing is the integration equipment, the payload change-out room, I'm pretty sure the 747 can carry all of that. If not, it can be moved via shipping container. So they can really send it anywhere in the world. Anywhere there's a runway for it to take off from. They can send it, which is actually really cool. That's a really unique capability, and it's a really interesting way to do this. Now, don't get me wrong, this type of technology where you launch a rocket off of a plane to go up into space, that's called stratolaunching in aerospace engineering. Stratolaunching, like I said, is where you drop it off the plane and it flies up into space. This isn't the first stratolauncher. There have been other ones. Another one that I can think of off the top of my head is the Lockheed L-1011 called Stargazer that Northrop Grumman uses to launch their Pegasus rocket into space. That's been around for a while. So this isn't really the first stratolaunch thing to be launched off of a plane to make it up into orbit. But what Virgin Orbit is trying to do is lower the cost of stratolaunching payloads into space. I'm not 100% sure, Nucleotron. Maybe. This rocket can get to orbital, Sun Temple. The 707 also had a fifth pylon. It's a good design. It's a good way to do things, Sebi. That's a really good design. It just shows the versatility of the 747 platform. Yeah, pioneered by the X-15. Yeah, the X-15 was the first one, but the X-15 didn't make it into orbit. Now, the benefit is that you can fly up to 30,000 feet and launch your rocket from there. So your rocket doesn't need to be... So if you have a rocket and you launch it off the surface, right? A certain rocket, like a rocket of the same size, if you took something like Launcher 1 and launched it off of the surface, you wouldn't have as much payload capacity as you would than if you launched it at 30,000 feet, like what they're going to do, right? But so that would seem to suggest that every single rocket should be launched from an airplane. The thing is that this really only makes sense for a small sat launcher. Basically a rocket that's no bigger than Launcher 1 if you're doing a stratolaunch, right? The reason is because, well, this makes sense. Stratolaunching payloads make sense if you have an off-the-shelf launch pad like a L-1011 or a 747, right? Making a plane that's bigger than this to carry a bigger rocket would mean that you'd have a plane that literally couldn't land on any runways because it's too big. It's not that we couldn't make a plane do that. It's that the whole point of this is low cost, so you have a low cost solution. Your launch pad is a 747, so that's pretty low maintenance comparatively to some rocket launch pads out there. Rocket launch pads require a lot of maintenance. But the reason why you wouldn't launch a Falcon 9 sized rocket off of a plane is because no plane exists that's strong enough to be able to move a fully fueled Falcon 9 anywhere. That plane doesn't exist. That plane would need to be like 6 times the size of a 747, and who knows how many engines it would need. Hey, Torlav, only 100 more months to go. 54-month resub. Very cool. Thanks, man. Nucleotron, that didn't launch off the AN-225. The AN-225 was used to move the Buran orbiter around. Stratolaunch is about as big as a stratolauncher can get. Yeah, you really wouldn't want it to get any more. Like this. Yeah, bend it like that. Mm-hmm. Where was I? Oh, here, I'll unmute for a second.
The Space Test Program, who you are and what you accomplish.
Absolutely. So the Space Test Program has been around for a long time, over 54 years. And the job of our job is to demonstrate technologies, upcoming technologies, to accelerate development of war-winning capabilities for the joint warfighter. Our job is we do this by taking those technologies, do the mission design,
cool.
The vehicle procurement, we do the integration, launch, and operations.
Acton, you said that the 747 engines can fit in the cargo hold of another plane. That's actually really cool. Smart idea, man. Joe Sutter, dude, did that guy know what he was doing or what? Joe Sutter is the chief engineer for the 747. I'd have to say they broke the mold when they made that thing.
This is critical because the Space Test Program is helping the Space Force, the Department of Defense, Space Systems Command to go after the threat and make sure that we stay relevant and the equipment is ready to do the mission and support our brothers in arms.
Excellent. Now, this mission is part of the Rapid Agile Launch Initiative, or the Raleigh project. Could you tell us a little bit more about the goals of that project specifically?
Yeah, absolutely. So the Raleigh, which is the Rapid Agile Launch Initiative, is one of those. It was a congressional initiative.
I haven't, Kristen.
And it was meant to help a venture class launch, small launch providers with using commercial practices to come and be able to support the mission of the Department of Defense. And the idea of those activities to be able to leverage new technologies, new processes, new equipment, and see if we can actually leverage and have a more resilient capability associated with the launch enterprise. And why is that important? Well, it's important because we need that to do our space mission. We at
That's an Air Force
STP, in
uniform.
conjunction with our brothers on the launch enterprise side, as part of Space Systems Command, are trying to push
problem,
that
Toshio. How are
technology
you?
forward, have a more resilient capability, so when we need it, it's there for us to deliver the capabilities that our leadership needs in space.
So there are 4 STP-sponsored payloads on the Above the Clouds manifest. How are those payloads selected by your organization?
So all the space technologies that STP flies are going through what we call the Space Experiments Review Board. And it's a
there you go. Wow, that's
DoD wide
Good.
activity where all the different agencies and services bring their upcoming technologies and the demonstrations that they need, and then they get rack and stack. And then once that gets approved
Stack
by
and rack 'em.
headquarters at Space Force, then we take those and then we execute to those. So once STP gets that list, then we work through our process, like I talked about, mission design or space acquisition or spacecraft acquisition, and then we go through that process and then we manifest, and that's how we got into this specific mission.
Excellent. So Cosmic Girl just took off. She and Launcher One are on their way to the drop point. It's going to get very exciting here soon. You know, in your view, what capability does this bring to the Space Force, the Department of Defense, and your mission partners?
Yeah, I think when it comes to mind is flexibility. We always looking for flexibility because we need to be able to act and be able to provide the technology not only that works, but also in a timely manner. And the concept that Vox has, where deploying from an aircraft, allowing that flexibility, because now you're not specifically attached to a specific ground point and the challenges that can come with that. So I think we're excited about seeing where this technology goes and the opportunity of that. This is our second launch with Vox. We did VP Alpha, and that went very well. We're looking forward to another successful mission, another opportunity to actually showcase not only the technologies that we have on board this specific capability or the specific mission, but also to showcase the ability of Vox to do their mission.
Yeah.
Well, thank you so much, Colonel, for coming on the program.
If you look at the graphics back here, these cool comic book graphics, the top one shows how they integrate the payload. They literally have a truck that's like the tanker truck that you'd find at the airport almost, with the exception of a couple of things because it's moving cryogenic propellants. That they load the vehicle up with fuel, right? And then this is the payload changeout truck. It's literally just a shipping container. So when he says flexibility, dude, if the Air Force wanted to launch a tuba into space, all you'd have to do is kind of come up with the adapter and have the FAA certify it for flight. And I don't think I don't think the Space Force needs FAA approval, but they might. But who knows? It's very rapid response capability. All they do is just there's one truck that loads the rocket onto the 747. There's another truck that fuels the thing, and then there's another truck that attaches the fairing and the payload, and it's all just based out of shipping containers. So 3 trucks, 747 in the rocket, and a runway, and you can launch this thing literally anywhere in the world, which is actually, that's pretty freaking cool. It's pretty good capability. What would you use to launch a small 2-seat electric car? Oh, Falcon Heavy. No, I don't think this thing has the payload capacity to put the Roadster into space, but it's still pretty dang impressive capability for what it is. Whoosh! This is the first fully liquid fueled air launcher, right? Yeah, liquid fuel. Yeah, semi-cryogenic on Launcher 1. That's a pretty big breakthrough technology. Found the chase plane. What kind of plane is it? Hello? It looks like it's a Cessna Citation. Yeah, Acton, they could basically set it to any heading, and you get any flight azimuth, polar orbit, equatorial, whatever. Heck, this thing...
Radiohead. I can report we have good signal, good tracking on all 3 ground stations right now.
Cool. I mean,
No good tracking.
this thing could
I like
fly
it.
to the equator and they could launch from there. It's actually, that's cool capability. My summer car, 7 stars. Either that or I'll go mess with the editor more. I think maybe...
We're level 30,000 feet, we remain in cloud.
Scope is 30,000 feet, still in clouds.
My summer car is for after hours, dudes, but if I have any energy left over from summer car, after summer car, I want to mess with the GTA editor again. That's fun. This makes me want to play a flight simulator, damn it. So what flight level is this? They're above 18,000, so they're flying instrument flight rules, right? Pilots, help me out. They're above 18,000 feet. They're flying instrument flight rules. This is flight level 310, right? $300?
Cosmic Girl orbit base.
Oh, they lost some altitude there.
Cosmic Girl, go ahead.
Eric's Unite.
Yeah, Cosmic Girl orbit base. On the S-turn maneuver, what we're really looking for is 30 to 45 degrees of heading change in 2 different
4,800
directions.
hours.
Standard INS realignment kind of maneuver.
1,000 plus flight test hours. Yeah, that's pretty good. Yeah, okay, cool. Above flight level 180, you switch to the standard barometer.
We haven't been briefed on S-turn maneuver.
Altimeter 2, Niner,
Say that
Niner
again.
2. FL 180 is about more about standard altimeter as opposed to local.
GNC converge.
You could be IFR
LCC, we're
under
currently
18,000.
I seem to believe the IMU is not currently aligned, so we're looking to do that maneuver that they're describing.
But Ishiku, you can't fly VFR above 18,000 feet, right?
Okay, that's copied. And can you repeat the
I
maneuver?
suppose you could, but I could have sworn somebody said it. I could be wrong. Yeah.
What we're looking for is 2 different heading changes, about 30 degrees to 45 degrees each direction. You probably won't be able to do that until you get into the Altrav airspace.
Cool, Electron.
Yeah, that's copied. We'll try and do that as early as we can to get an early call on.
Technically, you can do VFR on top above that, which is a specific clearance, but generally no. Got it. Class A airspace, FL 180, flight level 600. Class A equals IFR. Cool. What's that noise in the background? That's their communications, Sile. Yeah, that's just their mics feedbacking. With airplanes...
Above the clouds is our name for the...
With airplane radios, if I'm remembering right, if 2 people are trying to talk at the same time, that's when it does the beep! Because it gets everybody to shut the hell up. Because, yeah, there was a thing one time. If I'm remembering correctly. I could be pulling that out of my tail.
4 SCP-sponsored payloads.
Gary, blocked!
demonstrate flexible,
I'm pretty sure they made the
responsive,
radio
non-traditional
yells at
launch
you if you try to
capability
talk
for
over
the US
somebody.
Department of Defense. Let's take a closer look at these payloads. The Pathfinder for Autonomous Navigation, or PAN experiment, demonstrates a low-cost, adaptable autonomous rendezvous and docking solution using 2 3U CubeSats designed with modular subsystem functionality. Technology Education Satellite 13, or TESS-13, is a 3U CubeSat experiment sponsored by the NASA Ames Research Center, exploring novel capabilities including nanosatellite class machine learning, exobraking for rapid deorbit, and advanced communications. The Global Star Evaluation and Risk Reduction Satellite, or GEARS-3, is a 3U CubeSat sponsored by the Air Force Research Laboratory to explore how a prototype patch placed on the exterior can provide details on spacecraft health via commercial satellite network connectivity. And in addition to these 4 STP-sponsored payloads, the Above the Clouds manifest also includes 3 commercial rideshare satellites. Polish new space company Sat Revolution is flying their Stork 3 and SteamSat 2 satellites.
Dzień dobry.
Stork 3 joins the Stork 4 and Stork 5 MARTA satellites, placed in orbit by Launcher 1 on our 2021 Tubular Bells Part 1 mission, as part of Sat Revolution's Earth observation capabilities
does, tech
with a
guy.
focus on customers in the
now I can't
agricultural
even hear
sector.
it. Oh, why would you do
SteamSat
that?
2 is a technology demonstration for Steamjet Space System UK's
Something like that,
innovative water-field thrusters for in-space propulsion.
So pull in Ken into space?
And finally, as a late call-up addition to the Above the Clouds manifest, from final approval to full integration in less than 24 hours, is Spire Global's Adler-1 satellite. This 3U CubeSat mission is the first privately organized satellite of Austria, tackling the challenge of micro space debris, small particles with high velocities that can pose a serious danger to orbiting satellites.
Austrian.
A
No,
partnership
debris, no,
between
that
the
is so
Austrian
not
Space
right.
Forum, Findus Venture, and Spire, Adler-1 focuses on detecting nearby objects too small to detect from the ground.
Cool.
This nanosatellite detects space debris via a radar and using a piezoacoustic sensor that vibrates on impact, literally
Pizza?
a microphone in space.
Pizza sensor.
Findus Venture is financing the mission, and the Austrian Space Forum is a space research organization with more than 250 volunteers from 20 countries. To these 7 payload teams, welcome aboard Launcher 1, and we wish you 100% mission success as you go above the clouds to use your technologies for the benefit of all of us back here on Earth. Now, let's hear more about the TESS-13 satellite in particular and the amazing team behind this satellite. Go ahead and roll the video.
PSO's a microphone. Yeah, I know. But also, it's really fun to say pizza. Ow! Ow!
This is TechSat number 3.
Ow!
This is our second flight on Virgin Orbit.
Thank you.
We're very
I'm
happy
awake.
to be part of. And this particular mission is a 3U nanosatellite, and it's full of
Mark.
rather interesting and innovative experiments. We're
Look at
very
that thing. It's a
cognizant
little
of
tiny-
orbital
tiny
debris,
guy.
and so by having a
Sure
drag
know
device
how to
that is
hydrate a
simple and reliable,
Look at
that
that
means
little
that we
guy.
can bring our nanosatellites
Oh,
down
look at the dispensers.
and dispose of them
Wrecked
a lot
in a
faster, not
dispenser.
having them as a potential debris for other satellites or human vehicles to run into.
And I'm really happy to be part of the ExoBreak team. So I was involved in the design and the building phase of the subsystem. So we are a small team, and I really want to acknowledge one of our colleagues, and I call him like the hero of TechSat. He's really quiet, really discreet. His name is Alejandro Salas, and he's our lead ops engineer.
This will be the first of a series of flights that will begin to expand on machine learning in space.
Today, we got a chance
Cool.
to go in the clean room, do the final voltage testing, and then with the help of the Virgin Orbit team, we were able to integrate the satellite into the flight dispenser. Today was a really smooth process that my team and I hope Virgin Orbit team also enjoyed.
We command and control satellites through email, which is very unique, and we pioneered that some years ago, and it works to a
It
great
did,
extent.
Swishy,
We
yeah.
got injected into a perfect orbit, and that was a year ago, and then 9 months later, the satellite still sends lots of valuable data, so it's up there. The timing will be such that we'll have 2 satellites in orbit at the same time, thanks to Virgin Orbit.
I think TechSat it's really important from a NASA standpoint, but also for the entire space community. TechSat group gives an opportunity to entry-level engineer to really be part of a space mission, and I think you change the entire space ecosystem because you get a chance to fly your own payload. When I was doing my master's degree at San Jose State University, I was already part of the TechSat team, and that's where I started working on the ExoBreak. So over the past years, I was able to work on 3 ExoBreaks. To be the first female customer, first of all, I was surprised because I was greeted here by 3 or 4 women, right, at Virgin Orbit. So I felt like
That's cool,
home.
man.
They were all the personnel here. It's really, really nice, and they make sure we have everything to complete the integration.
We're just happy to be here again, and we look forward to 2 more flights in the next calendar year.
Thank you. Thank you to my team. Thank you to Virgin Orbit, because I also think that it's a great collaborative effort. And during this challenging year, we were able to work together, put a satellite together, and today integrate. So we are all, cheering for Virgin Orbit right now and hoping for the best.
About a half hour until launch. She's Virgin Orbit's Cosmic Girl has been in the air for about 38 minutes. Current speed airspeed is 422
So for
miles an
those
hour.
watching a live stream today, what
flight
you've
level
most likely
310.
seen in the background is a number of graphical user interfaces, or GUIs. Now, these GUIs are composed of some of the parameters our launch team across Virgin orbit are monitoring to make sure they keep track of the health and status of both Cosmic Girl and the rocket. Let's go ahead and take a look at one of those GUIs. These GUIs will show captive carry, stage 1 extent, and stage 2 extent. The current GUI that we have on the screen right now is for captive carry. To give you a little breakdown of what you're seeing on this GUI, let's first focus on the primary section of this one.
Stop saying
Here
GUI,
you see animation or a comic version of the rocket itself with a couple of our tanks overlaid on top. Those tanks represent our fuel and liquid oxygen tanks. Here you can see the fill level. Obviously,
already
since
at
we're still
cruise
captive
speed
carry,
username.
they haven't decreased yet. Up below the rocket, you can see some of the other components that comprise our rocket, like Newton 3, Stage 1, Inner Stage, Stage 2, and the payload. Here, we're tracking some of the key parameters like temperature and pressure.
That's pretty cool
Across
that they
the
show all
bottom of
this.
this GUI, you can see some other information regarding both Cosmic Girl and the rocket pertaining to bus voltage, the speed and altitude of Cosmic Girl, which you can see is flying at 420 miles per hour at an altitude of 31,000 feet, as well as our pallet and pylon, which is our separation system for the rocket. So by all means, stay tuned throughout the rest of today's mission and take a look at these GUIs as they update, as they'll provide plenty of information
Just keep
on
this.
the relevant
I just want to
section
look at this.
of our flight segment.
So that's the first stage engine. That's stage 1 fuel oxidizer, stage 1 fuel temperature, stage 1 fuel pressure. All right. You have your inner stage temperature. Okay, so they're using a pneumatic separator right here to separate that. First from the second stage, and it's reading 4,000 psi. It's probably inside of a composite overwrap pressure vessel, probably something about like maybe the size of a soccer ball or something in here. It is probably grouped with the ullage propellants or the ullage gases, if I had to guess. Then you have stage 2 fuel temperature. And then you have stage 2 pressure. LOX is pressurized. Remember that. The fuel tanks don't need to be pressurized. That's why they're showing ambient pressure. And then you have your payload inside of the payload fairing temperature, which is because it's outside at 30,000 feet. It's actually a little bit on the colder side. The fuel is RP1, Clem. Yep. So this is the hydraulic pressure indicator for the separator mechanisms. I'm not sure why they have nitrogen and helium here on the pallet. The pallet is the red piece that's attached to the pylon. So it seems like they have a hydraulic separator mechanism. So there's a hydraulic clamp that's holding the rocket there, and then the clamp will let the thing go. Like that. There's the pallet right there. I'm not sure why they're carrying nitrogen and helium on the pallet. They should have nitrogen and helium on the rocket. But yeah, the guy just said it was for their separator systems. Maybe the pylon will pressurize the fuel for flight. Yeah, possible. Oh, God, that reminds me of the crash course map in GTA. Yes, that'd be right. Mojave.
Discovery, go at throttle up.
That's where it launched from, Mojave Spaceport, Mojave Air and Spaceport in Mojave, California, which has a population of 3,763 people at an elevation of 2,757 feet above sea level. They actually use the high desert for storing planes here. There's a commercial aircraft boneyard at Mojave. Everybody stores their planes there because there's no precipitation at this altitude, and it's the desert, so it's very warm and it's very dry. Rocket launching beats to relax and study to. Oh, jeez, Fishio. Why are you gonna glaze over the Saberliner? Was that a Saberliner at the beginning? That's pretty cool. It's the aircraft, Ivo. Launcher 1 is launched from a 747, so takeoff time was when the 747 took off out of Mojave. The release time to shoot the rocket off is in about 22 minutes. Currently, Cosmic Girl is flying at about 31,000 feet with a cruising speed of 415 miles an hour, which is, what is that in knots? 420 knots, actually?
Let's go ahead and take a look at a highlight reel of Cosmic Girl in Launcher 1 taking off from the Mojave Air and Spaceport earlier today. That occurred at about 1:38 p.m. Pacific time.
It's a 747-400 Hokie. It was built in 2001, and it was operated by Virgin Airlines before this. Oh my God, that is cool.
And there we go.
Look at the airplane boneyard.
The girl is up and away.
Oh my goodness. That's so cool. I know, Swiscio, but this is you're failing to realize that Virgin Orbit and Virgin Galactic are two different companies. Dude, I'd love to fly on this thing and watch that rocket yeet off the side. Look at it; it's got a rocket under the left wing. Yeah, storage, make sure. Airlines store the planes there, and when they need spare parts for other planes, they just take them off. Yeah, we'll just call it storage, you know. They got a word for that, though.
So once again, what we just saw was Cosmic Girl taking off. That actually happened at 1:38 PST, so that happened a little bit earlier.
It's fully
today.
fueled at liftoff,
But I'd
Hokie.
also like to take this time to give a shout out to our flight.
It's a Carolox rocket,
we have
too.
Two pilots
Pretty rad, huh?
Eric Bibbert and Matthew Staney Standard, as well as 2 launch engineers. So thank you all for your hard work in making sure our rocket gets to the drop point.
No, thank you, host man. Okay. Yeah, Maggie was saying earlier, Eagle 20, Fox 2. Oh yeah, I was doing the math backwards. So 360 knots, that's actually pretty slow. That's pretty slow for a 747, but then again, you're carrying a fully fueled liquid fuel rocket on the side, so. Eric Bippert is the chief pilot. He's been flying since 1986, 4,800 flight hours and 1,000 flight test hours. Cool. We got Stanny flying right seat. He's an RAF test pilot with 3,000 flight hours and 200 flight test hours, and he's a flight lieutenant. He's an RAF test pilot? All right, that's pretty cool. Yep, she's speeding up now. Sounds like it leveled off. Oh. Wait till it goes, Glittrub. But yeah, I know what you mean. Surprised they aren't showing the speed in Mach. Well, 500 miles an hour. What's 500 miles an hour in knots? So you need to divide that by 1.15, not times it. So 489 knots and speeding up. So that's like 0.7 Mach, something like that.
Losses at the point we are in the flight. All ground stations are operating as expected at this point.
Copy. Ground stations acting as
Used to fly with the red arrows. That's cool. But is there a difference between you shutting up and you not shutting up, S-Master? Yes, there is. So shut up. No, I'm just kidding. Yeah, I mean, there's airspeed and then there's ground speed. And even indicated, that's all different, yeah, because airplanes. You're welcome. Steady. Whoosh. push. Ah, yes. Bring me the telemetry. Yeah, see, they're gonna have to chill this motor down, but they're not gonna do that right away. What they will do is as we approach the drop point, this temperature indicator should go down, indicating that they're starting to prime the engine and flow propellants into the motor to thermally condition it and basically make it so it doesn't hard start. You don't want to hard start a rocket engine, especially one that's attached to a plane. Good news, I can now confirm I have good video for my GoPro and Slick 40 this morning, editing it and uploading it for your enjoyment soon. Right on, Vulcan. It was, dude, that launch this morning was so good. They had, I'm sure you've seen it, but the track of the RTLS in the first stage, turn around and then fly, oh. That's so freaking cool.
So as Cosmic Girl carries our rocket out to a drop point, I wanted to give you a quick rundown of the flight profile you'll see our rocket complete today.
It's going to go up.
To help visualize the flight path of the rocket, we have put together a little graphic for you.
See?
Once again, to start this segment of our mission, you will hear the pilots yell, release, 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 when we're prepared to drop the rocket. 3 seconds after drop, we will ignite our propellant settling thrusters, followed shortly by our main engine start, which will pitch our rocket up and take us through the stage 1 flight phase.
See, I told you it was going to go up.
Through the next 150 seconds, our rocket will go from subsonic to hypersonic speeds as we climb up in altitude
past Mach 5.
About 5G in acceleration.
You need to be going Mach 25
At this point, the main engine,
fast
or
enough to get
Newton
into
3,
orbit.
will throttle down until all of the propellant has been expended, and we will transition to main engine cutoff, or MECO. Post-MECO, we'll go into a short coast until it is safe for stage 1 to separate away from the rest of the vehicle.
Yeah.
Post-stage 1 separation, the rocket's second stage engine, or Newton 4, will begin its first run phase. At this point, we will have reached a huge milestone for our mission and will have made it to space. This will also mark a point where it will be safe to do fairing separation and set up our system for payload deployment. Around 500 seconds after the start of this portion of flight, we will have reached our transfer orbit and the second engine will cut off and end this first run phase. Next, we will see the vehicle enter into a maneuver we call the barbecue roll in order to ensure proper thermal balance across the vehicle. From here, we'll fly for about 30 to 45 minutes until we reach the apogee of our transfer orbit. Once we reach the desired point, we'll reorient the second stage for a quick second run phase of the Newton 4. This point will be very exciting as we have reached the final desired orbit and we will be ready to deploy the payloads for all of our eager customers.
It's trimmed, Zeke.
As we're flying and progressing through our mission, we'll definitely try to call out all of these milestones.
So the 747 has equal fuel balance and it's trimmed. It's trimmed to carry that load on the wing. They messed with the aileron trim a little bit. So planes like this have fine adjustment and that fine adjustment called trim is where you basically can zero the control surfaces. So when you zero the control surfaces, like the ailerons, for instance, are designed for roll. So one goes up, the other goes down. The left aileron is way up. Because the plane would want to do this all the time. So they have roll right trimmed into the vehicle, trimmed into the 747, so it flies straight. So when that means, because you wouldn't want to have like fuel on one side to try and balance the rocket. When you let the rocket go, the thing would just flip. You don't want to do that. You want to make sure that when you release, you go straight up and away and then turn. So the 747's trimmed out to compensate for the heavy rocket on one side. You wouldn't want to use fuel balance to balance that out. That's asking for death when you separate. Because think about it. You separate the rocket, where does the 747 center of mass go? It goes out over the right wing. And then the center of lift goes to the left, right? Or the center of lift doesn't really change. It might shift to the right a little bit. And that'll make the 747 basically do this. It'll want to fly sideways. Yeah, you don't want to do that. Bad idea.
Texas for now. But anyways, getting back to it, the barbecue roll. So it sounds like a very technical aeronautical terminology there. What is it and why do we do it?
Right, so it's simply a slow spin about the roll axis.
Nice.
So launcher one will orient itself and slowly spin for what we call passive thermal control. So with respect to the position of the sun vector, we want to make sure that
I think it would take
components
too
on
long.
that second stage and our payloads
I wouldn't do
don't
that.
get too hot or too
I mean, I'm
cold.
not the smartest
and so
guy
we
when it comes to
slowly rotate, just like
flying,
a good
but I
barbecue.
wouldn't do that. That's dangerous.
Man, that is making me hungry. Now I'm definitely going to have to go look on a food delivery app and see what the closest best barbecue is around here.
We'll be right back.
Okay. This is the first time they've done this. Yeah. It's pretty. Yeah, this is the first time they've done this. We'll be right back. Alex, I'll take uncomfortable for 100. Ilya, привет. Добрый вечер. Someone went off script is gonna get a little talking to. No, the guy didn't go off script. He didn't sign them out. Guys, trust me, I have a lot of experience with live casting. You can't just make the joke and just stare at the camera after. You have to be like, and we'll be right back. And on that note, we'll go to a commercial. We'll be right back. You have to test out. Not test out. What's the word? There's a word for it. I forget what it's called. And on that bombshell, we go back to the studio. The word for it is not that. A segue. Yeah, you have to sign out. Yeah. Close out. There's a word for it in show business, Shardies. I forget what it is. But yeah, you got to do that so you don't prevent the cast from just kind of ending like this. That would be bad. You don't want to do that. You have to wrap the segment. Yeah, that's the right way to do it. Or right way to say it, I think. Okay, this is cool. I actually like this. This is a live shot of the telemetry. Not everybody has the balls to show the telemetry, which is actually pretty cool. That was unnatural enough to bring you out of lurk. Don't do that. Why? I always think it's funny. Yo. Lo-fi hip-hop beats to chill and launch rockets to. No, stop! Yeah, goalie, right? This seems like the kind of music that you'd listen to in a place called like Club Q or something. And Club Q is in the former industrial district of some city, and it's full of hipsters.
For our mission name for today's launch, we thought it'd be a wonderful opportunity to celebrate the innovators we work with in the Virgin Group history, which, of course, all started with music at Virgin Records. Above the Clouds is a single by the artist duo Gangstar on their hit album Moment of Truth, which was released by Virgin Records in collaboration with New Tribe Records in 1998. We named this mission Above the Clouds to pay homage to Virgin Records, the company that started the Virgin brand. We went around the factory here in Long Beach and let some of our teammates listen to the song. Let's hear what a few of them had to say about it.
It'll pitch up, Sile, and to the right. Kind of think of it like the 747 goes up and it lobs the rocket up on a trajectory.
On Virgin Records, but this is exciting because He even talks about going into space on this song too, so.
Well, first of all, I haven't seen a turntable since I was a kid, so it takes me back a long way.
Back in high
45,
school, we were
man, hell
staying
yeah.
at house parties and really enjoying the underground atmosphere that
See,
Gangsta
very
provided.
underground at Club Q.
Above the clouds, infinite skills create miracles. Yeah, that's talking to my head.
Gangstar, I'm a big fan. My favorite producer, that's DJ Premier. My favorite MC, Guru, rest in peace. My favorite Wu-Tang member, also featured on the track, Inspector Deck.
Wu-Tang Financial.
This
You gotta
song is
diversify
pretty
your
dope.
bonds,
I like
brother.
the music, the beat is pretty good. Upbeat, love it.
Oh yeah, I bet, dude. That's
And
dope.
I love hip hop. I grew up listening to Gangstar, Wu-Tang. I spent most of my time just on the beach and listening to this stuff, so reminiscing. And I just don't think they make music like they used to. So
I think so,
It's
Schnuck.
awesome. You know, it's not every day that a company does something cool that involves hip hop.
Good beat, interesting lyrics. Dope beat, it made me move.
It's dope!
And if something makes me move, then it's good. So,
The beat is dope, son.
definitely a thumbs up.
I think my daughter would be very proud of me that I'm in it and I'm not like, you know, I'm not a boomer, but she says, "Hey, boomer," you know, and they can stop
Yes, you
calling
are.
me office grandpa in the office.
Gangstar, loving it.
I like it. That's a great song to name our next song. Be successful just like the song was.
And I just want to say it's an honor to
That's
pay homage
dope.
to Gangstar in this next launch.
So let's keep playing on. Go Virgin.
If you have to say you're not a boomer, that's awesome. That got called out right there. Oh my god.
During the flight to orbit, Launcher One will be transmitting a signal containing key mission information.
Yo, get the guys that
on
were
Mission
talking about
Control
hip-hop
Center
to host this
operators
cast. They'll be
back in
cool.
Mojave.
They'll be fly. That'll
So
be
shown on the
perfect.
screen now are the locations of the ground antennas that we will use to capture this telemetry stream broadcast by the Launcher One rocket on its way up to
the
orbit.
8 members of the Asian
Telemetry
Dawn
is on a radio
Liberation
frequency
Front.
or RF signal containing critical
about them in
information about
Time
Launcher One's
magazine.
subsystems, performance, and the environments that Launcher One and its payloads will be experiencing during the various phases
Stop
of
it!
flight to orbit.
Stop it!
And the ground station shown on this graphic here will receive
will
that
in a
signal
second, Swishio.
and send the data on that signal to our Mission Control Center for monitoring, processing, and to that rocket status GUI that Spencer has been showing us
Stop
here on this
saying
live
GUI,
stream.
just say user interface. So you can actually kind of tell the trajectory that this rocket is going to take. It's going to basically launch due east from the latitude that they're at, and it's going to go down here and go back up. The ground stations are in line with the orbital inclination usually. Is it not a graphical user interface though? Only weird Gen X people say GUI. Just say UI. GUI sounds strange. They say GUI because they are in it, right? Enraged? There you go, exactly. I'd love to see sign language interpreters do some Wu-Tang. And konnichiwa, chatters. Konnichiwa. My phone can't tell what the stuff is. Can you explain all the bars in the picture of the fuel tanks? Nope. It's not on the screen. There, stage 1, LOX temperature, LOX pressure. Stage 1, fuel pressure. They had second stage LOX pressure, second stage LOX temperature, second stage liquid fuel temperature, second stage liquid fuel pressure, fairing payload, ambient payload fairing temperature. Oh, that's cool. Go bad. Nice. Sad Revolution's the Polish one, right? What is this? A 747 is gonna launch a rocket up into space here. Dzień dobry. Go bad. Right on, man. That's cool. Yo, I kind of want to listen to that song. What was that song called? I'm gonna mute the sound for a second. You know, we'll just. What was that song called? Dobry vai. Yeah, all right. From Rocklock. Cool, man. I'm probably not saying that right. My Polish is just terrible. Above the Clouds by Gangstar. All right, let's hear it. Oh, it's got JFK in it. The JFK speech about the moon is in it. Thanks, Thomas. Yeah. Yeah, this song's dope. Straight up. Really, Vasya? That's strange. Yeah, this is dope. I mean, it's no Pharaoh Monch, but it's good. The whole album's a banger. All right. I can't listen to it on stream. They'll get mad at me. Get the frick up. Simon Says, get the frick up. Sorry, that's a different song. Yeah, it's pretty good. That's pretty good hip hop, if I do say so myself. Now, don't get me wrong, I'm not the biggest hip hop connoisseur around. I don't know what gave it away. But, it's pretty good. I like it. I mean, it's from a time when getting a record deal meant you had to be good. And you know what the funny thing is, dude? That's the kind of hip hop and rap that I actually listened to. From like 1987 to like 2003. Not really much of a fan of much after that. I know about public service broadcasting, Novus. That's cool, yeah. I think every SoundCloud rapper just cried. Yeah, grab Shark, I could say words over a song and then pretend like it's a lyric. If I just pause at the right time, I can make it sound like I'm singing. But I'm not. I'm just talking to you over a beat. Then that makes me talented. Yeah, no, hard pass. Yeah, see what I mean? See, chat's already like, stop! Yeah. Pretty sure these, like, it's like Rick Tamlin, like, oh yeah, I love lamp and carpet and desk. Just saying things that you saw? No, I love lamp. I love lamp. Lamp. What is a separation bottle? I'm not sure what the pallet separation bottles are for. Mic drop. Good freestyle. Don't quit your day job, though. That was the... Never mind. I like the way you joke about this not music. How long till she drops? About 5 minutes. Good hip-hop reference. Real hip-hop. Real hip-hop. Yep. Let's see. Harry Mack, he's on Twitch Freestyle Rap, that kind of stuff. Cool. Right on. He's very it. Please don't talk like that. real hip hop. Don't you ever forget it. It's the underground stuff. And it's the white boy that said it. Hey, boss. Oh my God! Stop! Seriously, like, I'm muting. When will you learn that your actions have consequences? When will you learn? You ruined Sonic. When will you learn? When will you learn that your actions have consequences? You freaking fricks. You laughed. Don't be like, oh, EJ, that's terrible. You laughed. Come on. You laughed. Boston. Oh, look. Boston rap at its finest. Yeah. Do I look like I know what a JPEG is? No, sir. I just want a picture of a goddamn hot dog. Hot dog. There's water in the exhaust. Rap with Bill Nelson's voice. Well, I tell you, the proof is in the pudding, and I ain't kidding that the proof is in the pudding. Apollo 8. I don't know. Primo, make it stop. Okay, we should be getting time to drop, man. All right, here we go. Bars. The missile knows where it is. It knows this because it knows where it is.
Miguel, accelerating.
Copy, accelerating.
Base LE2 confirmed rocket is on internal power.
Okay.
Copies, rocket on internal power.
Vehicle switched on internal power. They unplugged it from the 747 systems. Houston, we have a JPEG and a hot dog.
Good morning, food shall start.
For base LE1 and 4 chill is initiated.
Okay, engine chill is initiated.
Chill initiated.
They started flowing liquid oxygen and RP1
nominal.
into the first stage engine here. We're T-minus 1 minute 20 seconds out from the launch here.
Over base LE2, aircraft SN and Avis has confirmed to go.
Base copies, aircraft S-bin and AFS has confirmed go.
We're starting our attack run. Cable out, let her go. Detach cable. Oh, wait, no, that's something different. Sorry. Stay on target. Loosen up. Stay on target. What's the payload? It's a bunch of small sats, Jonas. 2 rideshare missions in 1 day. So they're dropping the rocket out of a 747. Yeah, it's underslung under the wing shadow. Really wish they would show it. Okay. 20 seconds till deploy. Come on, show us the telemetry. Okay. How feasible is this business model? Enough that they're doing it.
Hi, good morning. Vehicles in drop ready mode.
Copy, drop ready.
Okay, stand by for the 3 release call.
Paul.
Copy, Paul.
Please, for the love of God, show the telemetry or something.
No warning.
Oh. We're getting intermittent updates here. The airspeed has gone down.
Release.
Okay, 3 release right there.
Is drop ready, as we can see. Now, unfortunately, we're not going to have the rocket cam for the drop, but we should be able to acquire that telemetry right afterwards and begin seeing Launcher 1 on her way.
Okay, so the 747 had a decrease in airspeed, meaning that it was pitching up, and right when it
Looks
started...
like we made it above the clouds and onward to orbit.
Okay, first stage ignition seems okay.
We're above the clouds.
It's a beauty up here.
Max Alpha flight complete.
Oh, I want to see that telemetry, man.
Stage 1 burn nominal.
No, Finn, please. Oh, there we go. We got a rocket camera shot, but it's super overexposed. Whoosh, whoosh. The music, though, Jim, is... okay.
Max Q Alpha flight complete.
We get spoiled by SpaceX, don't we? Lo-fi beats to chill and launch rockets to.
Control room, we have switched back to the Long Beach dish for telemetry. On this band.
View it here.
LE1, can you repeat last?
Okay, 120 seconds into the flight. Vehicle's now going 22.
We are leveled off, and we have a pretty good view up here.
2400 now crossing.
So as
100,000
you all
feet.
might have heard on MCC, we were able to drop successfully and separate from Cosmic Girl. We have already passed a number of milestones on our way here. Currently, you can see the rocket is at 3,000 miles per hour. That's around Mach 4, 5, and so we're definitely cruising through. We already made through our supersonic regime.
Ouch, thing, damn. Roger Wilco had better comms than these guys. Oh, that's messed up. Telemetry's still going up. I'm pretty sure that's a live read on the far left over there, guys. The camera is superbly overexposed. Okay, 5,200 miles an hour, 211 feet. That's about 66 kilometers up.
Discovery, go at throttle up.
And they're about a third of the way into space, so they're well over 10,000 kilometers an hour.
Throttle down commanded.
Spivey! What's up, man?
Lieutenant 3 shutdown confirmed.
Uh-oh. Okay.
Stay set. Brake wire's broken.
Okay. She's coasting from what I can tell.
And amazing views that we're seeing right now. The blue has gone to black, and that is the limb of the Earth in view. Launcher 1 is in space.
It did cross the Kármán line. They're going to coast for a second here.
Fairing brake wire's broken.
Okay, fairing separation is confirmed. We can see it in the camera right there.
So what you might have just seen on the video is we just had successful fairing separation from stage 2. And our actually, you can perfectly see the satellites right now. And that's an absolutely gorgeous view of our system in space.
So
yeah, look at that. There's our integrated payload stack. Again, to our 7 customers, welcome to orbit. You know, if we have more time in the schedule before the payload deployment, but Launcher 1 is in space. What a beautiful sight.
And we're getting word now that we are having great connection with all of our ground stations.
It should be well into that coasting period. This is Virgin Orbit, not Virgin Galactic. Two different companies, Fim. It's so true, dude. So we're at 330 seconds into the flight here. The next step in the flight is at T plus 527 seconds. Should be... So they've already gone through staging. They coasted for a second, fairing separation. So they staged separation at T plus 187. And then the next step in the flight is N4. So this is the second stage engine cutoff here at 527 seconds, which should be soon. And now they give us telemetry. So check it out. Interesting. Switching to internal power, switch the voltage bus to 31 volts from 24. That's very strange. I'm not, I don't know why I do that. I don't know enough about freaking electrical engineering.
Stage 2 PU nominal, halfway through burn.
Power unit is nominal. That's what they call it. You see the gimbal. The gimbal vector controller is right there. Chamber pressure temperature, or chamber temperature right there. Chamber pressure is right there. This is the nitrogen tank that's being used for ullage repellents. As the fuels are draining out of the vehicle, they fill the fuel tanks with nitrogen to keep the pressure inside of the tank stable so they can feed the engines correctly. You have fuel and oxidizer pressure right there. And then you have... actually, they're using nitrogen and helium. So this is a pretty good UI, yeah. We had a little bit of a drop in the signal right there. That's what that blip is. Oh, come on. This is a nice view of Mexico. Whoosh, bush. Whoosh. Almost all the time, Clayton. Thank you.
Listening into mission control, we just heard that we're over halfway through our stage 2 burn, as you can see on our GUI on the screen.
So we have a nice steady acceleration on that second stage, indicating that the engine is on. The acceleration will slowly go up over time, because as the rocket drains fuel, it's less mass for the engine to move, and the thrust on the engine stays the same, so the acceleration goes up over time. That's pretty standard for a G-load on a rocket second stage. Pretty good. We have... So over here is speed in miles a second. Okay. Nice. And then time in seconds over here. And then you have your altimeter over here, and then delta T down here. You're changing time. Miles a second. What's orbital velocity in miles a second? 7 miles a second or something like that? How many kilofeet? 5,280 feet per mile, and they're 4 miles a second. So 4 times 5 is 20, and then carry the zeros. So let's go 21,000. So 2,100 kilofeet a second. Kill me. So this is a shot of the ground track, but...
Newton 4, shutdown confirmed.
Okay. 520 seconds into the flight controllers are called nominal second stage engine shutdown. They should begin the barbecue roll maneuver here at 534 seconds. So you should hear the call for that. Whoosh.
Okay. Coast started, barbecue roll started.
Okay, that's good. A little bit behind on the timeline there, if this is right, if that's the correct time. The barbecue roll is to ensure...
So we just heard from Mission Control that we just shut off Newton.
Uniform, to ensure uniform heating on the vehicle, to make sure one side of the vehicle doesn't get too hot, so they slow roll the thing on purpose.
And now launcher 1 is going to coast all the way out to orbit apogee, and there Newton 4 will burn a second time.
Of signal there.
And after that, we will deploy our 7 customer payloads into that mission orbit.
That looked like it was slightly below nominal. The blue line, I think, is nominal trajectory, and it looks like we're slightly below it. Unless I'm not reading this correctly. We are slightly suborbital. 16,800 miles an hour is below orbital velocity. They will fire the second stage engine again at 2,821 seconds, which is, what's the T plus met time there? 2,800 divided by 60. So 45 minutes past. So, okay, it seems like they established apogee, and then they're going to circularize on the other side of the planet. So it's going to be about 30 minutes from now. We did hear...
telemetry is beginning to go intermittent on S-band.
Copy that.
They're
That's
reporting
LD on control.
Reporting intermittent telemetry on the S-band.
Release the airspace in the LTRAV.
Second.
Don't we need to wait until we're over land?
I think that was loss of signal as expected.
Do we need to wait till over land? Stand by. The answer is no. Our FA rep is shaking. Oh, okay. Then you are good to release. Copy that.
Okay. Yeah, this is indicative of a loss of signal. It didn't stop. I'm Ron Burgundy? Keep in mind, guys, this is their... Wait, is this the first time they've done this? This is the first time we've had a Virgin Orbit stream. They didn't stream the previous 2 attempts, if I'm remembering correctly. I love LAMP. I love LAMP. I love LAMP. Not the first time? Oof. Third launch, first stream. Yeah, okay, that's what I thought. So yeah, if the production's a little you gotta give them some time to find to get comfortable with doing this kind of stuff. SpaceX is a lot more experienced than this. The illustrations, though, are pretty baller. Yeah, these are all 3U CubeSat buses, so literally like half the size of a shoebox. Very small.
Ground on control.
I will, proceed.
Copy, you on control?
Are you good to get going with this?
Yep, can do.
Sounds good. I'm going to be handing over to LC2 here.
No, that's just the main loop, Rage. That's cool that they're streaming all this, guys. Don't give them crap for doing this, seriously. It's cool that they're letting us listen in on it, and then they have the stones to show us the telemetry on everything. Not even SpaceX does that. SpaceX just gives you velocity and altitude, which is still fine. That's cool. But these guys were showing like fuel tank pressures and ullage gas pressures and nitrogen thruster system pressures and payload fairing ambient temperature sensors. That's really freaking cool, actually. Not everybody does that.
Discovery, go at throttle up.
A bunch of different customers. Crank Pratt.
Control room, this is GNC.
Guidance and control.
Go ahead, GNC. SECO 1, orbital allowance, apogee of 524 kilometers, perigee 194 kilometers, 45 degree inclination.
See if he calls it nominal.
Could you repeat just one more time? Apogee is 524 kilometers, perigee 194 kilometers, and inclination 45 degrees.
Copy all. Thank you, GNC.
I'm not sure if 524 was their insertion altitude.
Plane getting off comms for a few minutes.
Copy that plane.
Yeah, see, this is sick. I wish everyone did this. This is quite cool. No RP, guys. It's intermittent. They had a loss of signal as expected. Talking about more rappy. Oh, jeez. Yeah, no, that's cool, Forge. This is not my music. This is the stream, dudes. The lo-fi, that's the stream. So we gotta wait till they have a reacquisition of signal to see what these numbers say, because these numbers are wrong. They don't have it. Basically, they don't have an antenna pointed at the rocket. It's tough to do that because, you know, the rocket goes over the horizon. So your antenna that's on the horizon, you can't see it when it goes over the horizon. Just give them a second to acquire signal. They'll be all right.
Well, how awesome is this? We have successful confirmation that Launcher 1 is coasting and barbecue rolling in her transfer orbit out to apogee, but the mission isn't over yet. So be sure to follow Virgin Orbit on social media for more mission updates to follow, including confirmation of payload deployment.
Don't you end the cast
We
now.
want to thank everyone who tuned in for
Don't
our
you end
Above
the
Clouds
cast now,
mission today.
Erica.
We also want to thank our customers for flying with us.
Stop it!
And a special shout out to our live stream production crew, brand team, and my co-hosts Paul and Spencer.
Don't you dare end the cast
I want to
now.
also give a special shout out to all the engineers
Spencer?
and technicians who I can hear on mission control right now,
Spencer?
cheering in the background. They have been working diligently and they've been working odd hours to make sure both Rocket and Cosmic Girl were ready to go today so that we were successful for our mission.
Yeah, Bill, I know, right?
We've entered into commercial service and we are delivering on our commitments to our customers, because here at Virgin Orbit, we release,
repeat.
Take care.
Don't you end the cast now. We did great. And we're clear. Don't stop the stream. Don't. You didn't even complete your own damn mission timeline. Stop it. Stop it. Hey guys, I got a question. I had the cast muted because I was explaining things on the stream. Does anybody here have the cast open by itself? And if so, did they say they were going to cut their... Did they say in the cast when they were explaining the mission profile that they were going to cut the coverage early? Did they say that? Now I'm wondering. Now I want to go back and look. Because if they said they weren't going to cut the cast early, and then they cut the cast early... Because I'll tell you what, man. Look. The blue line is where it needs to be. The white line is where it is. I might be crazy. Call me crazy, but that seemed like an off-nominal insertion. The timing was wrong. Unless these numbers weren't accurate, they called barbecue roll. The barbecue roll was 10 seconds off of the mission timeline. Now, I know that might not seem like much, but even the slightest mistake with something like this, if they did, I don't know if they did, even a late call like that is something that probably should be noted. And then the cast literally went to crap after that. And then the flight director called GNC for the orbital insertion values, which indicated a 524 by 190 at 45 degrees inclined, 524 apogee, 190 kilometer perigee at 45 inclined. And then they were talking about telemetry, and then they shut the stream off.
Did you finish the tag-alongs earlier, or did I do that?
You did that.
Okay, thank you.
Yeah. Go back to the procedure graph they showed earlier in the stream. Yeah. I don't know, man. Call me weird, but I've watched plenty of space webcasts in my day. When the comms go silent for a second and then they sign the cast off, yeah. It should be a 500 kilometer circular orbit at 45 degree inclined. Yeah, 524. All right, Paul. See you, buddy. Yeah, they kind of just yeeted out of that cast real quick. But the hosts of the cast were celebrating, so maybe it's fine. Who knows? Did Virgin Galactic release pre-flight TLEs for the payloads? I don't know. And after that they were left with single prop percentage before loss of signal. Here, let me back it up a little bit. So that's the last live shot we got there. Let me look and see if there's anything here. They're paid to celebrate. There's no other option. I already have the mission schedule opened. They signed off the cast before payload deployment, which is why, Forge, I'm asking, at the beginning of the cast, did they say they were going to cut the cast early? Hey, Rocket Guy. Rocket Guy, we had something. I think something weird happened here, but I don't know for sure. Well, there isn't really anything to stream right now, just confirmation of the Burns and spacecraft deployments. Going off of the last streams, these happen when they have no signal, okay? Rocket Guy, I'm not familiar with Virgin Orbit's track, but that looks off nominal to me. And they were aiming for a 500 kilometer circular at 45 inclined, and it was a 2-burn insertion. So second stage engine cutoff establishes apogee, and then second stage engine burn at T plus 45 minutes indicates a 500 kilometer circularization. They cut the cast right after second stage engine cutoff, and I noticed that they called out on the main loop that the signal was intermittent, and they didn't say as expected or anything. And then they lost telemetry on the vehicle. I don't know. It may have been fine. And then they just signed off the cast kind of abruptly right after that. The cast sign off seemed all right. But I don't know. That doesn't sound good. The flight director was calling the GNC. He called the GNC on the main loop and asked for the telemetry insertion numbers. Ooh. Yeah, he asked for them twice. Yeah. Yeah, that could be a thing, Admena. There were national security. There were Department of Defense payloads on this. Remember that they don't have to show or tell us anything. Everything they did so far is... we're not talking about the quality of the cast, Swishio. Don't get confused. Yeah. Let me go back to and see where their ground stations were. If they have a ground station in Baja, California, then... They showed it real quick. I'm trying to find it in the telemetry, or in the cast here. Last prop values were 5% RP1 and 8% LOX. Then when they cut to telemetry, it started dropping altitude. Yeah, that could have been due to an intermittent signal. Yeah, Don, it could be that. Yeah. Please see 9 minutes in drop time. Okay, so T plus 8 minute 48, velocity is 15,603. That's like 95% of the way to orbit. 600,000 feet is a little under 200 kilometers. Miles a second above 4. Acceleration steadily increasing at 2.5 Gs. That looks right. Stage 2 voltage dipped slightly below 31 for a second. Ground stations mentioned. Thanks, C22. Let me see. They do have a ground station in Baja, California. Interesting. New tweet. Okay. As planned, we're waiting for the rocket to coast halfway around the Earth, deploy its payload and downlink telemetry. Even when you're moving 20,000 miles an hour, it takes a while to orbit our planet. 20,000 miles an hour. Are you going to the moon, or? Yeah, Thomas, there is a ground tracking station in Baja. Okay. Hold on. Yeah, there's a tracking station right there. They should be in line of sight. I'm wondering here. I mean, it seems like everything went okay. We had some live shots. I don't know. Let me listen.
Coast started. Barbecue roll started.
Okay. See, that was off time. 9 minute 53. That was not on time. The barbecue roll per the mission profile should have happened at 534 seconds. Let me just do the math. 534 divided by 60. Yeah, that's that can't be. Yeah, Shado, that could be a thing. Interesting. Hey, Aerospace. I'm just going to listen to this again here real quick.
So we just heard from Mission Control that we just shut off Newton 4. So that was our SECO 1. And we've begun that maneuver that we mentioned earlier called barbecue roll.
It could also be a bad connection in the data buffering. Yeah, that usually doesn't happen when you're in direct line of sight with a tracking station. Their tracking station is Like right there. It's right on the coast of Baja right there. Interesting. Wrong Seco's at 8:47 plus or minus 2 seconds. Plus or minus 2 seconds is okay because there could have been a delay in the telemetry came here, but yeah. That's very strange. I don't know. You know, yeah, see, look at how far off nominal that is, man. And then for some reason the line, it turns blue. I wonder what that's about. Maybe there was something wrong with the Baja update. Good reference. This seems like it's slightly off the track, but I could be wrong. And they did have a slight voltage drop. The blue line's a side quest. Yeah, good. Yeah, you're right. Good call. Let me just watch this part again.
Rule satisfied. 30 seconds to Seco.
Hey, Clayton.
Tranquility Base here. The Eagle has
Thanks, buddy.
AFSS mission rules satisfied. 30 seconds to Seco.
Right on, man. Thanks for the tip. Can I just...
AFSS mission rules satisfied. 30 seconds to Seco.
30 seconds till second stage engine cutoff would indicate a 9-minute... What is it? 9-minute, 27-second second stage engine cutoff? Let's see what happens. Oh.
Newton 4, shutdown confirmed.
Okay. Guy gave the call at 9:28, so that was right. Yeah, curious that the altitude went down there. Does the speed go down? Nope, speed is going up. 87. 88. 51, 46.
Newton.
This is junk. This is junk data. These numbers don't make any sense. Those numbers don't make any sense. You can't be decelerating and falling at the same time. That's not how that works, especially at that altitude. It's got to be junk data, guys.
4, shutdown confirmed.
That's got to be bad telemetry. That's defying the laws of physics, those numbers. Stuff in dot space isn't in real time, 04.
Okay. Coast started, barbecue roll started.
Yeah, look at.
So we just heard from Mission Control that we just shut off Newton 4, so that was our Seco 1, and we've begun that...
I'm going to go ahead and guess because the cameras are very intermittent that this data is intermittent and probably wrong. So, yeah, that's what I'm going to guess. Honestly, this could be something as simple as a wire coming unplugged that goes to the antenna on the rocket. That happens more often than you might think. It might be a little bit off, Hibbit, but that could be for insertion purposes. What's up? What? Maybe the barbecue rule made the antenna point the wrong way. Yeah, I don't know. Accidentally jettison the altimeter? I don't think that's ever happened, Dan. And if it has,
earlier called barbecue rule. So we just heard...
Here, let me... Hey, Get back here. Yeah, that's called a rud. Yeah.
Okay. Coast started. Barbecue roll started.
We're not sure, Forlorn.
So we just heard from Mission Control that we just shut off Newton 4, so that was our SECO 1, and we've begun that maneuver that we mentioned earlier called barbecue roll.
And now launcher 1 is going to coast all the way out to orbit apogee, and there Newton 4 will burn a second time, and after that we will deploy our 7 customer payloads into that mission orbit.
On the Ariane launch, it drops for a moment. Yeah, but if it's dropping in altitude, Gene, that usually means it's increasing in velocity. That's kind of how physics works. So I'm not entirely sure that that's what's going on. I think it's just junk data. Yeah. Forge linked this a little bit more. Watch the velocity indicator on the far left of the screen. 16,882. You guys see it over there? Watch that. Yeah, I'm pretty sure that's junk data. Yeah. So none of these numbers or anything can be trusted, which means if they say it's good, I'm inclined to believe them, because that's not right. That looks like an overflow. Whoa. Yeah, no, it went to plaid. That's what happened. It's going 13,050,216,584,542 miles an hour. Ludicrous speed! Go! They've gone to plaid. Maybe that's why they couldn't track it. Yeah, but if the telemetry's junk, that's not really going to work. How many minutes left until SES-2? Oh, I don't know. Went through the screen wormhole. Yeah. The DoD payload was a warp drive. It's Zuma 2! Zuma Boogaloo! Wow! Can you guys mix the audio correctly, please? Holy crap. Whew. Wouldn't that be out of the solar system in like 15 seconds? 13 trillion miles an hour? It would take a little bit. Since it's a DoD payload, we can't tell much of anything from the telemetry, sadly. Yeah, James, you know, I was thinking about that, and I'm pretty sure if if the Department of Defense was worried about where this payload was going and what orbit it was going to, they probably wouldn't have said the insertion numbers on stream. I'm just putting it out there. Yeah, I'm pretty sure the DoD thing can be we could put that myth to bed. What fraction of C is it? That's what I'm trying to figure out. But it's giving me scientific notation. So 6.706 times 10 to the 8th. That's fast. I know it's about 300,000 meters a second, but what's 13 trillion miles an hour in meters a second? That's A lot of zeros, man. That's a lot of zeros. It's about 2/3 C. It's pretty fast. Nice. How many AU? Zonic, you're asking for velocity in distance. How many AU a second? Oh, I don't know. Yes. What happened? The cast was a little weird, German, but I think everything is fine. This is why Imperial needs to be banned. Yeah. Or you could just stop being a wimp about it. One AU is in about 8 minutes, yeah. Yeah, alright. Well, that was 2 rocket launches for the day. Not bad. Pretty cool. I'll switch us over to space news. It's been a pretty long stream, man. It's roughly 350. Yes. More space news than my summer car than maybe GTA. Zonic, I started 2 hours early today. I don't know if I should push it like that, dude. But yeah. Let me see. There's not... Let's see. Let's take a look. Alright. There's some stuff about nuclear engines here. Let's check that out. And then we heard more about Boeing and NASA's Starliner. Boeing made NASA had made a statement about the NASA safety panel statement. I'm looking around for anything else. Relativity video. Okay, we can start with a relativity video. Let's see. I'm going to turn the air conditioner on because it is getting really, really freaking hot in here. Well, not the AC. Fans. You don't need to run AC right now. There's plenty of cold air outside. All right, let's see what this relativity video is about. Ooh. What happened to people behind you? I wanted to change it up, so I got rid of them, Scrub. They're there in spirit. They're just kneeling at their desks. But it looks like they're working. Alright, this looks like a full duration burn, whatever it is, on, I'm not sure which engine this is. The Aeon vacuum engine at Stennis. Yeah, that's a 3D printed rocket engine working right there. Upper stage for Terran 1. Description has more info, yeah. Here at Relativity, we recently completed our first Aeon vacuum full duration mission duty cycle, which ran for 310 seconds. This is the longest Aeon engine testing we've ever completed. Previous record was 196.58 seconds and represents the full time that a second stage engine will burn on its way to space. Cool. Cars, Elon, planes, Crash Bandicoot. Nice. Full of, like, 90% 3D printed that thing, which is pretty impressive. Yeah, he said duty. How big is this engine? Not very big, Mab. Look at the railings. It's like maybe a meter tall, at best. So we can print one of these at home. I mean, if you have like a $300,000 laser sinterer, aluminum powder laser sinterer, sure, geek, yeah, you too can print rocket engines. All right, so that's cool. Good test from relativity there. What's this? This is coming from Kines, so... Oh. Ariane 6 umbilicals, from what I can tell. Aluminum, no way. Yeah, Da Vinci, it's probably Inconels or something, you know. It's probably not aluminum. You're probably right. Look at the umbilicals. That's cool, man. This is the mobile launcher for Ariane 6. Do we have sound? Well. Clunk. Oh, look at it. It's on a damper. You see it slow down at the last second? That's cool. That's really neat. I don't know what this thing is. Oh, those are the umbilicals that they installed. Oh, look at that. And look, they got two P120C test article boosters right there. Either that or they're real. Hello. Very nice, eh? Please last. It's space news material. No more space is a rocket engine test. Oh, neat. That's really cool. This is a nice little rocket engine coming out of Australia. Nice. Ariane 5? No, Ariane 6. Oh, yeah. It's not a mobile launcher. I forgot about that. Ariane uses a fixed pad with a mobile service tower. Interesting. They build the rocket directly onto the pad. Yeah, see? The ML, or what? Not the ML. That would be a fixed service structure. Is right onto the pad, along with the launch plates. Cool. And then those are the umbilicals that they were testing right there. One of them is oxygen, the other one's hydrogen. I want to see those things close and open again. That was really cool. Yeah, it's kind of like Delta almost, Thomas. Interesting. Wait, what was that guy spraying on that? Anti-seize? Oh no, grease. Locks and LH2 connected to the SRBs, or did I see that wrong? Swishio, why the hell would they connect the locks line and an LH2 line to an SRB? Why would they do that? They're for the core stage, man. They go around the boosters. These guys are tightening up the pipes. This is all the plumbing here. I'm trying to see what plumbing. Man, look at the springs. The springs to absorb the impact of the umbilical into the closed position. Yeah, those things are pretty powerful. So the umbilical is usually on a counterweight. So this is why, like, tail service mast carriers like these things, they're so tall. Look at the door right there. See, that's person sized. It's pretty crazy, right? And this thing is built like a freaking tank because it needs to withstand the blast from the rocket engines. So how this usually works is the umbilicals are on a wire. And that wire is on a pulley, and that pulley is attached to a counterweight, kind of like an elevator almost. And when the umbilical goes to disconnect, so when the rocket goes to launch, right, the first thing that happens is they let the weight go. And when they let the weight go, right, it pulls on the umbilical and it looks like it undoes the latching mechanism. Because if you notice up here, the cables are the first thing to go taut here. See, it pulled them back. And pulling that little lever back looks like it unlatched the umbilical, which is actually really neat. And then the wire pulls the umbilical taut, right? The weight goes down and it pulls the umbilical back. And then the springs right there, the springs that are right there, and then the shock absorbers that are right there absorb and dampen the impact, which is actually really cool. Play the video. And it all happens in less than a second. Yep, that unlatches. The cables unlatch the umbilical, which is actually pretty smart. And then the weight pulls the umbilical back. It hits the springs, right? And then the tail surface mast umbilical hood closes. There is also shock absorbers for that right there. That's a hydraulic damper right there. Yeah, Sonic, it's very satisfying. Very satisfying seeing that thing slam down and then at the last second go. Tss. It's like the kitchen cabinets that you push them in and they go in and then they stop like right before they slam and they go. Tss. You know what I'm talking about? Dampened kitchen cabinets. Yeah, see, the whole mobile service tower is on rails. It moves. They build the vehicle right on the pad. These are test articles. They're inerted SRBs. These are inert replicas of what's called a P120C. P120C solid rocket motor is an Italian solid rocket motor, and it's also the first stage for the Vega launch vehicle. So Ariane 6 is an Ariane 5 core stage with upgraded engines, first and second, and it just has a bunch of Vega first stages attached to it, which is actually really cool. It's a really interesting design. Great, now I want to remodel my kitchen. Toilet seat techs. Toilet seat tech. Oh, yeah. Yeah, the toilet seat. Yeah, right. Are one of those shorter than the other? I'm pretty sure it's just the camera angle, dude. They're mounted diagonally at Mena because Ariane 6 can launch with 2 or 4 of them depending on how heavy the payload is. Pad's looking real good, though. All this concrete is brand new. They've made this in the past year. Does it shoot spaghetti from the bottom? Yes. My toilet seat is motorized. The open and close operations are done by motors. Why? It shoots baguettes. It's Italian, not French. And Swishio, there's a spicy meatball. The spicy meatball is used as the propellants. Okay? The propellants for the rocket. We just jam a bunch of meatballs inside of a tube. They're a very spicy meatball. And then we light them on a fire. And boo! Spicy, passionate meatball comes out the bottom. It makes perfect sense. Yeah, makes perfect sense. Yes, we use a lot of crushed red pepper in our solid rocket motor designs. Yeah, and there's the water tower. And then we call them space balls. I like not having to touch the toilet seat. The only person that touches it is our cleaner. You have a cleaner? Alright. That's cool. Yeah. I wonder why the umbilicals are yellow. Why did they paint them high vis? So this is the second stage fueling arm, right? Or fueling arms, I should say. One of them is for liquid oxygen. The other one is for liquid hydrogen for the second stage. for Arion. That's cool. You know what, guys? Oh, I just got the craziest idea. You know what they should do? The Ariane 5 core stage should like turn around, come back, and when it like they should try to land it like right here. And when they try to land it right here, they should bring these arms back in like that, right? Like that, and catch the core stage right before it crashes. So like it should try to give it a hug like that. Write that down. Write that down. Write that down. Brilliant, Monsieur. I'm not sure that's a good idea. What's the matter, Alex? Are you a chicken? Do you not like wine? Poulet? Oui, poulet. I'd love to see it soon. What if we use the strong back grabby arms to watch a Falcon 9 to catch a Falcon 9 first stage? No more LZ1. 5-Ed. What's up, Ian? How are you? Anyway, on to the next bit of space news. That's cool news coming from our European colleagues. Very nice. Chicon. All right, so yesterday we covered some stuff about Starliner. The NASA's Aerospace Safety Advisory Panel basically said that OFD-2 was a fustercluck, and Boeing responded saying, not really, and now NASA has issued a statement. Let's see. This is all covered by Thomas Berghardt, who is the news director at NASA Spaceflight. News! Sorry. Doing good, EJ. Still recovering from the phenomenal VO webcast. Right. You are the knight that says news. Yeah, Ian, it's pretty cringe, bro. Yeah, pretty cringe. Yeah, that cast will go in my cringe compilation. Don't forget the NASA voting rights bill. Oh, okay. So this is NASA's statement about the Aerospace Safety Advisory Panel. Not associate. That's not a word in that sentence. Okay. Crew safety is NASA's primary responsibility and top priority for all the agency's human spaceflight programs. The oxidizer isolation valve issue on Starliner's service module propulsion system that resulted in a delay of the OFT-2 mission was discovered during pre-launch checkouts after the agency's flight readiness review. Although the issue was unknown during the flight readiness review, the meeting is a thorough review of the body of work, including technical issues that have been closed or need to be closed prior to flight. During the standard FRR process, NASA and its providers will discuss and characterize a variety of both general and specific subsystem-related risks. It is not uncommon for NASA and our commercial crew partners to have differences in risk scoring on the magnitude of various technical issues being addressed at the review. This is because we use different rubrics or scoring systems for our risk assessments. Using different assessments can be healthy for the program as it allows management to better understand the total level of risk as the scoring systems look through different lenses to ultimately drive down risk and increase crew safety. That is exactly concurrent with what Boeing said in the statement above. Regardless of the risk scoring, every issue must have the proper technical rationale for flight. For Boeing's OFT-2 flight readiness review, all known technical issues were thoroughly addressed and worked by Boeing and the commercial crew program. NASA and Boeing agreed on the number of technical issues and risks, the flight rationale for launch, and all polling members of the reviewed polled go for the uncrewed mission, leading to the signing of the certification of flight readiness. My favorite part of the webcast is when they don't show the launch rockets. Yeah, but Ian, that song Above the Clouds by Gangstar is actually pretty good. And I'm not being sarcastic either. It's pretty good. But, I mean, if I wanted to listen to hip-hop, I would listen to hip-hop. Yeah. All right, Alex. But I just spotted this wonderful paper by Aerojet Rocketdyne on the use of NTRs on SLS. Yeah, that's the next bit of news that I have teed up. So, yeah, it's junk data. That's a, yep. You'd love to see it. Oh, we also got some SLS news. I will be putting that into the queue. El Hydra, thank you. So, fellas, with this right here, guys, it was exactly like, okay, I don't mean to be like I told you so here, but it was exactly what was predicted. The NASA, okay, so if we go back and read the original assessment from the Aerospace Safety Advisory Panel down here, they said, quote, equally disturbing was that the program got very close to launching the spacecraft before the stuck valve issue was identified. This is exactly the type of situation that the panel urges NASA to aggressively avoid as the agency proceeds with assigning Artemis contracts. Can't identify it if it didn't happen before the FRR. Exactly as I said the other day. It's funny because we were talking about this issue 2 days ago when we were talking about this issue 2 days ago for Space News in chat, and I said that look, there's no nefarious purpose from Boeing here. They wouldn't shoehorn the capsule to the pad knowing something was wrong, especially when they're forking over $400 million of their own money to do it. That makes no sense. And everybody's like, no, that it's a conspiracy. EJ Boeing is slipping up. No, guys, as predicted, the flight readiness review passed because they weren't aware of the sticky valve issue before the flight readiness review happened. Just as I said. Because, like I said, and I don't have any insider information or anything. I told you this 2 days ago. Do you think they possibly meant that they're upset Boeing didn't look too deeply beforehand? I'm not sure what exactly happened here. Yeah. Ian, that's one of those statements, and I'm not saying this about you. That's one of those statements that at face value seems like a logical thing to say, but is literally one of the stupidest things I've ever heard. How can you check to see parts failing before they fail? How does that work? Update from Virgin Orbit. Let's see. And there we have it, folks. We just heard from Mission Control that Newton 3 successfully reignited and deployed all customer spacecraft into their target orbit. Another fantastic day for the Virgin team. All right, cool. So everything was nominal there. Check for fatigue. Yeah, what's Boeing going to use? It's friggin' crystal ball? Yeah, good call, Dredd. Like, the safety advisory panel says, you had sticky valves from rolling it out to the pad. Have you tried checking to make sure that the valves weren't sticky before you rolled to the pad? Yeah. I'm pretty sure they wouldn't have rolled to the pad if they'd known the valves were sticky in the first place. Hello? Who's doing these safety advisory panels? Who's doing this? Go tend the damn snack bar, for frick's sake. How are you gonna cite safety? How are you gonna say that they should have investigated the problem before the problem happened? How are you gonna say that and file it in an official government report? Are you serious right now? Oh, Magic 8 Ball. Yeah. A little better than the crystal ball. Yeah, that's right. That's what I mean. This whole thing is ridiculous. The safety advisory panel said, well, maybe you should make sure your valves don't corrode before you go to the pad. And Boeing's like, we didn't know about it when we rolled out. The problem manifested itself after we rolled to the pad. And then the safety advisory panel basically said, oh, well, maybe you should check the valves more. Okay. And I'm not just saying this to gain favor with Boeing either. Why are you taking so long? This is ridiculous. SpaceX is eating your lunch, man. Come on. Okay, what did make them sticky? We don't know that, Eukerman. Like, but you can't diagnose a problem before a problem happens. This whole thing is ridiculous. Like, Ian, do you think I'm talking out of my tail here? Like, they said, oh, well, maybe you should make sure the valves aren't sticky before you roll to the pad. Even though this problem happened after they rolled to the pad, which is just, all right. Thanks, NASA. Very cool. Yeah, it's like, okay. If they hypothetically knew it was an issue, which they didn't, they could have ultrasounded the valves, but it was an unknown unknown. Neuro, which brings me back to my first point. Everybody here loves to harp on Starliner. They love to make memes, and SpaceX is eating their lunch, and it's pretty funny, actually. But at the end of the day, man, every spacecraft has teething problems, unknown unknowns. It's a thing you have to deal with. The control room is empty. Yeah. Ian, yeah, that makes sense. Like, don't just yes me to death, dude. Am I on to, like, dude, I literally predicted the outcome of this article 2 days ago. You can go watch the VOD, and everybody's like, no, that's not happening. Boeing just sucks. I'm like, no, okay. And now, don't get me wrong. It could have been chat screwing with me. That's possible. That is, I will not rule that out as an impossible scenario. That definitely could be a thing. It definitely could be a thing. Yeah, well, Boeing sucks anyway. Shut up. Stop doing that. Yeah, remember the P fan? Inspiration 4 remembers the P fan. Every spacecraft has teething problems, guys. Yeah, Alex, it's just the way it is. Sometimes space fans don't think it be like it is. But also, it do be like it is. They don't think it be like it is, but it do. Okay? But it do be like it is. You understand? I was shocked when the news first broke, but I'm thinking now that they're just asking stupid questions to ensure 110% that nothing was missed. Yeah, Ian, I'm going to go ahead and say that that's probably what's going on. The funny thing is that Boeing and NASA both agreed that they were wrong. I'm sorry, that's wicked funny to me. They literally cited in the safety report about how Boeing and NASA don't agree with each other and how that's wrong. So they agreed with each other about the fact that they were wrong about agreeing with each other. God, I love aerospace engineering. That's hilarious. Meat Puppet, what's that? I lurk all the time. This is exactly how an engineering critic goes in the Navy. They ask questions about every single thing that could or have did happen, then point fingers. Bro, it's freaking insufferable. It's freaking insufferable. This was the Aerospace Safety Advisory Panel, Shaw. Now, okay, here's the other thing, though, dudes. I'm kind of dumping on the Aerospace Safety Advisory Panel, right? I'm kind of dumping on them. But somebody said it already in chat. They gotta ask stupid questions just to be absolutely sure. The Safety Advisory Panel is a form of oversight. It's a check and balance to make sure that they don't get go fever. Even if they sit there and cite a bunch of stupid freaking reasons and demonstrate by citing these reasons that they have no idea how the program is working, it's still something that NASA and Boeing have to respond to and be like, oh, okay, well, that's what we're doing here and that's what we're doing here. It's like a check valve in the process to get the spacecraft up into space, which, as seemingly needless as it is, it's actually a good idea, and I'll just go out on a limb and say that. But it is kind of fun to dump on them from time to time. Funny thing is that the ASAP is made of former NASA employees. Yeah, but I don't understand why the Safety Advisory Panel would cite NASA and Boeing disagreeing with each other. If they were ex-NASA employees, they would know that having different metrics for they would know that having differential metrics for risk criteria is actually something that makes the spacecraft safer. It's not a problem. That's what I mean. You're making comments about stuff you have no idea what you're talking about. At least that's what's going on here at face value, right? That's what's seemingly going on. But I don't know that. I don't know that for sure. Like it. That's like saying the space shuttle has 2 solid rocket boosters. That's actually bad because there's 2. There should be. It would be simpler if there was 1. Like. What? What? Yeah, caveman, for sure. Yeah. Yeah. Okay, I think I've covered this sufficiently. I basically said exactly what happened 2 days ago. I prefer 3. I prefer 3. Yeah, I mean, well, Lumbo, you know what's funny? You're making a joke, and I know you're making a joke, and I acknowledge the joke, and I laughed. I got a sensible chuckle out of it. There was times where the shuttle flew with 3 solid rocket motors aboard. The 2 SRBs that make it go up, and then they carried another solid rocket fuel upper stage in the payload bay for the satellite, if they needed to put it on a far orbit. So there were actually times where the shuttle flew with 2 SRBs and an IUS upper stage, which is actually 3 SRBs because it's a 3-stage upper stage staging. James Bonk am having strong call of bondulance. What about 4? Russia did 4. Are you reviewing rockets? Review the Titan 3C. Yeet. Your review is complete. Congratulations. 10. Yes, 10 because we're really hungry. Eyes emoji. What is this? Normal things to see in the parking lot when you walk in for work. Oh, an Orion test article. Very nice. Very nice. Yeet. Alright, so, let's see. We have some SLS stuff and then Starship stuff, and then I think that's all. The ball bags are still there, which is... Yeah. Anyway, so we will start with the SLS footage with this B-roll footage from NASA. Take a look. This is footage of the Artemis 1 SLS in High Bay 3 right here. This is from the top of the launch umbilical tower, looking down at the crew access arm tests. Yeah. Mobile launcher white room retraction and CAA retraction test. See, there's the white room with black curtains. Watch. White room retract should go backwards a little bit, and then this whole thing will go zzz, it'll go over there. See? White room retract, and then... And then... Yeah, there it goes. Yeah, you might want to go backwards a little bit more than that. The rocket might hit that on the way up. And then... I am the cream. And like the cream, I rise to the top. Nobody does it better. I just want to note the scale of the VAB here. You know what's really funny in these time lapses? The people that are walking around on the transfer aisle gantries down there. Okay, so 2 things. That's about 250 feet below this platform right here. Another thing, it's about 200 feet down to the ground from that platform. So where this camera is like, oh, I don't know, 28 stories off the ground? Yeah. Just thought I'd let you know. See those people walking around in the transfer aisle? Yeah. That's 20 stories off the deck. This is... No, not 20 stories. 10 stories off the deck. This is 28. Yeah. Did you say yeet? No, I said feet. That's cool. Looks like they painted on the decals on Artemis. We got some Helvetica United States with the flag there. I do like that. And yeah, see, this is, so what they have here is failure to communicate. No, this thing is called a white room. The white room is a basically a sterile environment that the astronauts use to get into the craft before they launch, right? It is basically, it's an airlock, and it seals up against the side of the capsule, right? And there's another door right here, and the white room has HVAC ducting going into it that maintains positive pressure inside of it. So air's being pumped into it, and it's blowing out the door and out some seals here. It's actually blowing out the door seal over here. It doesn't blow this seal out. It pressurizes the capsule with a positive pressure. The idea is to prevent foreign object debris from getting in the capsule. You don't need like a squirrel going in and climbing into Orion when they go to launch to the moon. I don't think that would be a good idea. I mean, it would probably be funny, but not a good idea. So they have a clean room or a positive pressure sterile environment right before they get into the spacecraft, because you don't want to bring any dirt on the carpet inside of Orion. You don't want to track dirt into it. That's bad. I hate it when squirrels do that. Yeah, me too, man. Take Cool Hand Luke, for instance. He'd do what he want. Yeah, right? So that's cool. They did CAA retract tests here. Now, little bit of word on Artemis 1. Artemis 1 is the first mission of the Artemis program that's going to go into space. There have been test missions that are suborbital in the past. This will shoot an Orion capsule with nobody on board out to the moon for a little excursion around the moon and then back. That mission is scheduled to go off probably sometime in late March, if I had to guess. I hate squirrels. Yeah. Mm-hmm. The carpet really ties the pod together. Oh, I agree. It's orange. Like the pumpkins. That was a joke. Hang on. March 2022, we hope. Sorry, I had to talk to my mother about something. All right, cool. So, speaking of SLS news, here, let's check this out. So this is coming from Tough SF, author of the Tough SF blog, original super nerd. He has an anti-productivity field. All right. So the LEU nuclear flight demonstration vehicle proposed by Aerojet Rocketdyne, 2,000 kilometer safe starting orbit, 20 tons with 55 kilonewtons of thrust, 900 second specific impulse. For about 243 megawatts, for about 243 megawatt reactor power. The operational stage would be scaled up to 8.4 meters and 31 tons and launched on SLS Block 2. Hello everyone, is there somewhere I can learn more about rockets and space travel? Ozzy, stick around here. I'm not just trying to shamelessly plug the stream. If I can give you resources, but also, just ask me. That's what this stream is for. This stream serves as an introductory course to learning about rockets. So, if you stick around on the stream, yeah, just ask me questions, man. Tag me in chat. I'm always answering questions. Like, if you want to know what the hell any of that, hell all that stuff means, I could tell you, no problem. If not, how deep do you want to go? Because if you want to learn about rockets and space travel, that is a rabbit hole the size of the Grand Canyon. So how deep you want to go? How far you want to go down the canyon? You're like riding a space donkey down the canyon. Smarts through osmosis. Yep. Oh yeah, I'll be sticking around for sure. I just asked for out-of-stream resources. So Rocket Propulsive Elements, 9th edition, is something you're probably going to want to read if you're interested in rockets. That's real nerd stuff. RPE is good. You can read Wikipedia. Most of the stuff on Wikipedia is more or less accurate. Just sometimes the Wikipedia stuff has opinion inserted into the article, which is kind of stupid. There's no opinions in engineering. That's not how that works. There's numbers and everybody else can piss off. Just think about it. Any extra heat they could scavenge out of the nuclear rocket could be used to power high-thrust Hall effect thrusters. Agreed. 243 megawatt output. That's a lot of power for a spacecraft, Jaka. That's a big rabbit. Tell them about the rabbit. It's a big Twinkie. Normal chemical rockets, specific impulse is 300. 300 for Keralox rockets, and mid 300s for methane, 400s for hydrogen, to 400 to 450 for hydrogen rockets. Hydrogen can really go anywhere from like 380 second specific impulse to about 450. There are some that make a little bit more than 450 second specific impulse, but yeah, this is double the efficiency for the same mass. And anybody that knows a little bit about rockets knows that doubling the specific impulse is that's a very big deal. And they also plan to scale it for SLS Block 2, which doesn't suck. And it looks like they're going to launch a test article on Vulcan, which is pretty cool. Open up the PDF. Don't tell me what to do, you pillock. I'm doing it because I want to, not because you told me to, okay? Yeah, Ozzy, I'm sure I could find more resources over time. But yeah, start with those. There's also NASA technical resources. NASA technical... or NASA technical reports. NTRS. NTRS has all kinds of good stuff about rockets in here. This is basically a database of all the different NASA projects that they work on, and it's all public domain because it's NASA. So yeah, if you want to go read about the X-33, for instance, right, which is one of my favorite space planes that never flew, you can figure out stuff about its ground systems and facilities, testing and design, launch vehicles, propulsion and power. There's all kinds of good stuff. Here, let's go check this one out. Here, ready? Whoop. Can you link the tweet? Because you told me to. Because you told me to. Because you told me to. Here, let's go here. Yeah, NTRS is super useful. Yeah. See, here's performance about the X-33, how it works, what it does, etc., etc. I've read through most of this stuff because I tried to build one of these in KSP once. Like a real version of it, as close as I could get. Came out alright. Didn't scale very well. Which I believe is one of the problems they would have had with the big one. Funny how that works. Okay, so let's take a look here. Low Earth orbit plane change parametric trades. Delta Clipper, one ship to rule them all. Yeah, this is an NTR, a nuclear thermal, an NTR rocket, or NTP is what this thing calls it, nuclear thermal propulsion. 2,000 kilometers safe starting orbit, 20 tons with 55 kilonewtons of thrust, 900 second specific impulse. So that's a nuclear reactor right there. And they use liquid hydrogen to cool the nuclear reactor so it doesn't melt down. And that liquid hydrogen expands because anytime you heat something up, it expands, and liquid hydrogen turns to gas and gets shot out the back of the nuclear reactor in a rocket nozzle. Yeah, nuclear thermal. This is a nuclear reactor. So because it's a nuclear reactor, it also generates power. You can generate power, and you can also fire your rocket engine. These things are where the Apollo program was going to go. The Apollo program, in fact, tested a nuclear engine. This works. They tested it on the ground, and then the Apollo program got canceled. They were going to make a nuclear-powered third stage for the Saturn V, which would have, I don't know if it would have doubled payload capacity to the moon, but it definitely would have been a significant increase. If you had a Saturn V with a third stage that had a nuclear engine in it, making 900 second specific impulse, that's well over double the efficiency of the J2X. So your TWR would have gone down because the nuclear engine is a little bit heavier, but your Delta V would have probably doubled. Nah, maybe not doubled. Almost doubled. Close. Specific impulse, Ozzy, is the miles per gallon. Specific impulse is a measurement basically of how fast the exhaust gases are coming out of the nozzle from the rocket. Higher specific impulse, the more efficient the rocket motor is. So ISP is like the miles per gallon for a rocket. The best we can do right now is about 450 seconds with a hydrogen second stage like a Centaur or a Delta IV second stage. This nuclear engine that they're planning on testing makes double that, literally double. So double the efficiency. So think about it like this: we're swapping out an engine. Yeah, I'll talk. I use car terms a lot, Ozzy, when I'm talking about stuff, or OC. So we have an engine that makes 500 horsepower that gets 20 miles to the gallon, right? And we're swapping it out with an engine that makes like, 200 horsepower, but it gets like 100 miles to the gallon. It's a big difference. You lose thrust with 55 kilonewtons right there. You're losing thrust over the chemical rockets, but you're gaining you're about half the thrust of an RL-10 and double as efficient. So if all these numbers basically correlate to the range of the spacecraft. Not so much that one. This one definitely though. This correlates to the range of the spacecraft. Because spacecraft range is not measured in distance. It's measured in acceleration. So how efficient your engine burns has a lot to do with how fast you can accelerate. Because the name of the game with spaceflight is speed. The faster you can go, the further you go. So a spacecraft that can accelerate to 25,000 miles an hour is a spacecraft that can get to the surface of the moon. So the Apollo lander can be accelerated to 25,000 miles an hour because that's how spacecraft work. Their range is measured in velocity. Half the thrust, double the ISP. It can burn 4 times as long. The burn time is definitely a lot longer. Let's see if they show it. And it also generates 243 megawatts of power, which is enough to... 243 megawatts. That's enough to power like a factory. Yeah, that's a lot of power for a spaceship. They don't need that. They don't need that much power, but it would be good. So without H2, it will melt. No, not at all. Okay, Da Vinci, I have to go back into nuclear physics here. Give me a second. So with a nuclear reactor, in a kind of general sense, you have control rods, right? And the control rods are basically in a graphite encasement, right? And usually that graphite encasement is in water, right? Depending on the design. And your fuel rods, your radioactive fuel rods, the rate of neutron flux is controlled by what's called a moderator. A moderator moderates your change in flux. If you have more neutron flux, you're splitting more atoms. Splitting atoms generates heat. That heat is energy, right? So the more neutron flux you have, the more energy you generate, okay? Now, when all the control rods are inserted into the moderator, your neutron flux is at a low. Basically, you're in safe mode. You still need to run some coolant through the reactor because eventually it will melt no matter what you do. Right? But if you want to generate more power, you pull the control rods out. If you pull the control rods out, you're no longer moderating them with graphite. Okay? You're moderating them with water now, straight. Or whatever else you could use. You could use helium or whatever. Well, I suppose you can't use helium. Helium would be in a cooling loop, but it doesn't matter. So basically, the more you pull those control rods out, the more heat you generate, okay? Because more surface area of the radioactive material is being exposed, right? And more of it being exposed increases neutron flux, more atoms get split, more heat gets generated. Now, that is an axial control rod system, so it goes up and down and up and down and up and down and up and down and down. You don't want to pull it too far out because then it'll melt. You'll make too much heat. Nuclear power plants work as follows. You have the electrical power generation that you're making, and then you have your thermal energy that you're making. You have electrical energy and thermal energy. Those two aren't exactly the same. All right, you could be generating more heat than electrical power, right? You generally don't want to do that, but you could. I mean, you generally want to be pretty efficient as you can be. But thermal power and electrical power generally they fluctuate between, like, around each other, if I'm remembering right. Don't get me wrong, it's been a while. So basic nuclear physics right there. How does the Nerva engine work? It uses radial control rods. Yeah, radial control rods. You want to see? Here, hang on. I can show you.
Nerva technology reactor, given the letter designation NRX, was essentially the same as Kiwi.
Hey, Tog. Long time no see, man.
Had to extend its lifetime and put it into an engine configuration.
Watch.
Here is how the nuclear rocket engine will work. The reactor is a solid core, heat exchange type, cylindrical in shape. Fission of uranium atoms in the core is the source of heat.
That's what I was...
A reflector made of...
I wasn't sure on that part, but yeah, that makes sense. You're generating more thermal than you are electrical because of thermodynamics. You never get out what you put in, which makes... I mean, it doesn't matter if it's neutron flux, same thing.
Beryllium surrounds the core.
Here, let me rewind it.
Here is how the nuclear rocket engine will work. The reactor is a solid core, heat exchange type, cylindrical in shape. Fission of uranium atoms in the core is the source of heat.
Oh, right on.
A reflector made of beryllium surrounds the core. The core consists of many graphite elements impregnated with the uranium-235 fuel. The core contains a number of channels running down its length. Hydrogen passing through the channels picks up heat generated by the fission process. The channels are coated with niobium carbide, a material which resists the corrosion that would occur if the hot hydrogen were allowed to come into direct contact with the hot graphite. The hydrogen is stored in a liquid state to achieve the lowest possible volume.
Tog. It's good to see you again, brother.
The flight model will use about 1/3 of a million gallons for a 30-minute firing.
Watch this.
To start the engine, the cold liquid hydrogen at minus 420 degrees Fahrenheit moves through a pump down to the nozzle, through internal passages in the nozzle walls,
cooling channel,
and back up inside the reactor pressure shell and reflector. This cools the nozzle, the reactor shell, and the reflector, and at the same time warms the hydrogen. The hydrogen then passes through the hot fuel elements where it is heated to about 4,000 degrees Fahrenheit. From there, it is expanded through the nozzle to provide thrust.
If I remember, no more than that.
The bleed line carries some of the hot hydrogen back to drive the turbo pump.
Tap off.
The whole engine system is amazingly compact for a nuclear power source.
It's using a tap-off cycle like a
The reactor works through fission of uranium-235, which constantly emits nuclear particles called neutrons. When reflected back toward the reactor, these particles will set up a chain reaction, generating terrific heat. The heat is controlled by rotating rods installed in the beryllium reflector around the reactor.
Here you go, Da Vinci.
The rods are also made of beryllium, but one side is coated with boron, which absorbs neutrons.
There's your moderator.
Initially, the rods are turned so the boron side is toward the fuel elements, and sufficient neutrons are absorbed to prevent nuclear fission from starting. Beryllium reflects neutrons. By turning the beryllium side toward the elements, a point is reached where sufficient neutrons are reflected for fission to begin. The amount of heat produced depends upon the position of the rods.
So did you hear that? Okay. If that didn't make any sense, beryllium reflects, it bounces neutrons. So this thing is always trying to shoot off neutrons in every direction, right? And those neutrons, if they find another neutron, or they find another atom, they're going to hit the atom and they're going to knock that atom's neutrons away. The neutrons separating from an atom that's fission. You're splitting the atom. You're taking its neutrons away. And then those neutrons just fly around and find other atoms and knock their neutrons off. That's what flux is. That's what neutron flux is. Now, you have boron. You have a boron moderator. So the uranium is shooting neutrons at that boron and it doesn't bounce off. It just absorbs it. But when they move it and they move the beryllium in place, now you have a beryllium moderator, which is very bad at moderating. That's a good thing, right? It's a very bad mod. We should take away its sword. So those neutrons from the uranium bounce off the beryllium and they bounce back and they start hitting the uranium? They start hitting the uranium atoms and splitting those neutrons. And that creates a ton of energy if you split those atoms. Yeah, a lot of energy. That creates a lot of heat. Splitting atoms releases a lot of energy. Fusing them releases a lot of energy too, but one's fission, the other's fusion.
Heat increases as more of the beryllium side turns toward the core. When the desired rate of heat production is reached, the rods are turned back to stabilize it.
So radial control rod moderators. Moderating a uranium graphite core. It's literally a nuclear reactor that's shoehorned inside of a rocket's combustion chamber.
Heat decreases as the rods are turned back. When the boron side absorbs enough neutrons to halt the fission process, heat is no longer generated. These rods can be operated by remote control.
God, I hope so. Oh yeah, they had functional test articles, by the way. Yeah. And don't worry about the engine spewing radiation. The hydrogen isotope that comes out of this thing actually has a really, 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 really short half-life. So it's not spewing radioactivity out. It is for a second, and then it dissipates really quick. High half-life on that hydrogen isotope. Yeah, crazy. A moderator, Synerd, but yeah. Mm-hmm. Yeah, right? Can you imagine, Spraz? A guy on the rocket engine. Crank the rods into the right position, Joe! Okay.
Test facilities for engine components.
Yeah, see, Chernobyl is the opposite of that, Tism. That was a radioactive cesium isotope that had a very, very long half-life. Yeah, that's not good. You don't want that.
Were built near Sacramento, California. The problem? Get adequate performance with minimum weight.
Anyway, so Aerojet Rocketdyne is working on bringing the nuclear propulsion stage back, which is good. That's a good thing. That's what we want. Rough calculations with 900 specific impulse and mass from that tweet yields 4,500 meters a second delta V. 4,500 meters a second. Wait, K-Mir, is that with this one? Is that with that information or this information down here? Yeah, Jaka, that's teething problems. That can be fixed. Photo number 2. Yeah, this is the test stage. Holy crap, the test stage will have 4,500 delta V. No payload, only 16 tons. Gross. Oh, no, never mind. Yeah, no, not interested. But also, an 8.4 meter variant could be, that could be useful. Payload injected to... Really, NASA? Payload injected to Uranus, NTP stage off NASA SLS Block 2. Yes, I know. So this nuclear stage, if they launched it on SLS Block 2, could put a 3.5 ton payload on a trans-Uranus injection. And a 3.5 ton payload would take 14 years to get to Uranus. It's not fast enough. Pretty good news, though. That's cool that they're working on... they knew that they were working on nuclear propulsion, but it's good to have some good PDFs demonstrating the subject. Anyway. Oh, okay, Core. Yeah, sign nerd. NTP isn't as good as you'd think because the engine mass is high and the tankage is huge. I disagree, Max. I disagree. I think the potential for nuclear thermal propulsion outweighs the drawbacks from efficiencies there. Yeah, I know. It's not as efficient. Doubling your specific impulse is great, but your dry mass does go up with nuclear propulsion, obviously. I know that. But I can think of several reasons why, if we had a reusable nuclear tug going between Earth and the Moon, and, I don't know, filling up every time it got near the Moon with hydrogen that was drilled from lunar ice, and then we could use the oxygen for other things, like breathing, might be a good idea. I think that's much more sustainable in the long run because it's simpler. Nice, C-22. That's cool. Would that go Hiroshima if it popped on the pad like Amos? No. No, not at all. Nuclear... No. Nuclear reactors don't work like that, Goalie. You're comparing a flash bulb on a camera to a light in your house. Doesn't work like that. So think about a flash bulb. A flash bulb is a very, very high amount of light very, very fast. A lot of energy gets released all at once. Okay? Like a camera flash, like the big bulb. That's what I'm talking. Not like the one on your iPhone. I'm talking about a real one, right? It releases a crazy amount of energy all at once, very quickly. That's what a nuclear blast does. Okay, it's unregulated neutron flux. You basically try to push a block of uranium way past its critical mass, and the uranium literally divides by zero, and you're splitting like millions of atoms all at once, and the energy release is enough to flip an aircraft carrier end over end, right? So it's like a flash bulb. The light that you turn on in your house when you come into your kitchen and bring the groceries home, that's more like a nuclear reactor. It's a little bit of light over a very long period of time. Okay, a nuclear reactor, that can't be a flash bulb. You're missing the required equipment. I'm pointing at one of my green screen lights. That can't be a flash bulb. You're missing some things. You could try to flick it on and off really fast, but it's not gonna. It'll never give off the amount of light in the amount of time that a flash bulb would. Right? Nuclear reactors can't do that. The only time a nuclear reactor has gotten anywhere close to an unregulated neutron flux reaction was Chernobyl. And funny story, it's almost like if you take all the safeties off of the nuclear reactor, it does something you don't want it to do. I know. Funny story. That was the closest. But even then, that was like a fraction of Hiroshima. And Hiroshima was a dinky nuclear weapon comparatively to what we have now. The Earth-Moon tongue is one place that sort of makes sense. For everything further away, electric propulsion makes more sense if you're going to put a reactor in space. Yeah, I agree, Max. Yeah. But I'm always thinking about the manned element, not necessarily unmanned missions to like Uranus and stuff. That's cool, but it doesn't interest me as much as being able to take a taxi out to the moon, 2001 style, you know what I'm saying? But yeah, no, I'm with you on that one. Yeah, solar electric, man. Dude, how about a nuclear-powered upper stage with solar electric propulsion RCS? That would be nice. Yeah, I know, James. I know. Funny story, right? Or pushing vehicles with lasers on Earth. Ever heard about that? Yeah, Ivo, I know about that, but... yeah, I don't know, man. That might work. I think that would be a good idea for asteroid defense. Just literally shine a light on the comet or asteroid that's coming towards Earth and melt some of it, and that resulting heat that gets released will blow the asteroid off course. Yeah, it'll perturb the asteroid's orbit. You only need to do it by like maybe a meter a second when it's a couple million miles away, and it'll miss Earth by a very, very, very wide margin. There's an NTP concept on this paper called CNTR that looks to get about 1,800 specific impulse. Yikes. Wow. Cool. Even nuclear electric like the Russian TEM. That thing is freaking cool, Max. That's a really cool piece of kit. I really hope that thing works, man. Explain solar electric propulsion. So SEP King Kitten is, it looks kind of like a rocket engine, only a little bit different. You have a combustion chamber, and the combustion chamber has a positive and a negative node, and they flood the combustion chamber with an inert gas, and then they arc electricity through the combustion chamber, and the electricity ionizes the inert gas, and it actually produces thrust. It's a solar electric propulsion, or just electric propulsion, or a Hall effect thruster. Yeah, Hall effect thrusters are really cool. A lot of satellites use them. Gateway will have Hall effect thrusters on it for its primary propulsion element. Is the gas expelled? Well, it ionizes. When it ionizes, it releases ions. The electricity is like your oxidizer, right? And then the inert gas is your fuel. And when they ionize it, it releases the ions out, and those ions get shot out the back. And that's still mass shooting out the back of a nozzle. It works. Hall effect thrusters are extremely efficient. We're talking like, I don't even know, 3,000 seconds specific impulse or something. Like, they're really efficient. The problem is that most Hall effect thrusters that fly nowadays have less thrust than like a desk fan. Like, do this. That has more thrust than a Hall effect thruster. So they're super efficient, and they're great for keeping a satellite in one spot. But yeah, they're not really good at doing anything else right now. But the thing about Hall effect thrusters, King, is that they can be scaled. The only reason that Hall effect thrusters are really small, like a Hall effect thruster is maybe this big, like even the big ones are maybe about this big. The only reason they don't produce a lot of thrust right now is because most Hall effect thrusters are connected to solar panels. Solar panels are not the most efficient way of generating power. So if, for instance, if what Max is saying, if we launch a nuclear reactor into space and couple that to some scaled up Hall effect thrusters, you might be able to get a Hall effect thruster that actually has some kick behind it, that's actually useful for moving people around. And Max, I agree with you. Like, nuclear thermal is good, but that would be the end goal. And guys, this is all within the practical realm of physics. This is nothing new. Solar electric propulsion exists. Nuclear reactors exist. We've just never put we put nuclear reactors into space. We never built a spacecraft that's designed to be propelled like that. It's on the horizon though, which is good. And if we get that, if we had a Hall effect thruster that could generate 100 kilonewtons of thrust. 100 kilonewtons of thrust at like 3,000 seconds specific impulse is, yeah, that's like expanse-style things would start happening then. That's sufficient propulsion to explore the solar system. That's good enough. It won't take 14 years to get anywhere. It'll take a couple of months. Because you could just keep accelerating and just keep accelerating and just keep accelerating. Then when you're halfway there, you turn around and you decelerate and you decelerate and you decelerate. And by the time you get to your destination, you've slowed down enough to capture. Just like they do in the Expanse. That's actually not bullcrap. That's what we would need if we wanted to be able to move around the solar system like Inaros nowadays. You know what I'm talking about? Don't spoil anything. I haven't seen it. About another negative, which turned out to be Rockwell's 1972 full-scale concept model. Wow, that's one hell of a picture. That's really awesome, C-22. The city of Downey, California was working on getting it restored and into its own building back in 2012, but they ran out of funding in 2014 and it ended up here. Well, at least it's covered up, dude. Yeah, the Hall effect thruster with that much, with 100 kilonewtons of thrust could send people to Uranus, no problem. And maybe your mother, too. By the way, I think that the TEM engines are not Hall effect. There's a few different types of ion types, and Hall effect is just one, as you know. Yeah, I'm not sure. We'll just say electric propulsion and call it a day. Because, Max, if it's one thing I'm learning, the more and more I learn about engineering, the more I realize I know less about engineering. So sometimes it's just better to say you don't know. The problem is when I misspeak, which happens sometimes. And sometimes I just get it wrong because I thought I knew, but I don't. That happens. That's what I mean. The more I learn about aerospace engineering, the less I overall know about aerospace engineering. Some real Dunning-Kruger stuff going on there. I prefer Vazmir. Yeah, Vazmir would be good. My mother to Uranus? Why I never. The more you know, the more you know you don't know. Pretty much, Singularity. Yeah, it's strange like that. Anyway, all right, let's see. Some Rule 8 news and then some Starship stuff and we'll get going. I'm getting really tired of talking. I've been doing it for 9 hours straight, man. Today, I proudly reintroduce my bill, the U.S. Leadership in Space Act in 2021. This legislation would finally legitimize and provide further guidance for the Artemis program. My bill designates Johnson Space Center to serve as Artemis's program lead. This is especially critical. Great job. No, it makes sense. Yep. For the Hall effect drives, I presume the gas gets ionized to allow it to be accelerated by an electric field. Yes, that sounds right, Dragon, but electric propulsion is not my forte. I know way more about nuclear. Anyway, this is especially critical given the recent OIG report where recommendations to improve astronaut management, readiness, and training include better integration of Artemis objectives. This bill authorizes the space station operations to 2030, providing confidence in the U.S.'s commitment through the end of the decade, while a commercial successor comes online, providing a seamless transition while ensuring no gap in the U.S. access to low Earth orbit exists. It is time for Congress to work to. It is time for Congress to work together. It is time for Congress to work together. Sorry, I can't. It is time for Congress to work together to pass a strong bipartisan NASA authorization bill that sets the tone for a new era of space exploration. We must empower our great space agency, U.S. commercial industry seeking to grow and compete, and our foreign partners. I admire the optimism. No, actually, you know what the messed up part is? Space is actually one of the things that everybody agrees on. I mean, look. The last guy wanted to go to the moon. This guy wants to go to the moon. Pretty good example. And the guy before him wanted to go to the moon. The guy before him wanted to go to the moon. space is actually one of those things that just kind of gets quietly passed under the table, but it's almost like Congress never wants to admit that they agree on it. So they just kind of low-key just pass the stuff and just kind of go back to yelling at each other. No, seriously. That's how space policy works. It's kind of weird. Okay. Read my full press release. Loving this, Randy. Let's see. Discussion draft on page 9. National Aeronautics and Space Administration Authorization Act of 2010. The worst legislation in NASA history. This is an amendment to that Authorization Act. The administrator shall continue development of the exploration upper stage for the Space Launch System with a scheduled availability sufficient for use on the third launch of the Space Launch System. God, please make this happen. Okay. I'd be curious to go and read the rest of this bill, just out of curiosity. I'd be curious out of curiosity. Thanks for the very provocative words, EJ. Anyway. So, that's cool. If that... So, the U.S. Leadership in Space Act of 2021. I want to read that. I was about to just repeat the same thing I literally just said a second ago. I'd be curious to read this. Said that 3 times now. All right, cool, sweet. Okay, cool. I'll check that out later. If only dates from NASA authorization would work. Well, the problem is that they use other NASA authorization acts to change the original authorization act and push the stupid date out further. Why don't you authorize shutting up and going to the moon? Wait, what? No. I understand it's a slow process. I'm just trying to be funny. Anyway, here. Starship footage. Let's see what we got. This footage is coming from our buddies over at NASA Spaceflight, Nick and Mary, and also the NSF robots. Make sure you go over there and subscribe to the YouTube channel. It's NASA Spaceflight, all one word. Definitely worth the sub. And guys, you know me. I wouldn't plug this stuff if I didn't think it was worth it. I have a thing about advertising things that I think about advertising things on this stream. I don't advertise stuff I don't believe in. You can't get more America than this. Hey, EJ's brain, come on now. Oh, I like that. That's very nice, Goalie. Okay, so here they are working on the wide bay down in Boca Chica there. Steel workers are tightening down the bolts. I'm building this on the server where my old tall building is. Okay. I know this is in Texas and all, but dare I say it looks kind of cold there? That buffeting noise, though, that's what I want to hear. Authorize this. Yeah, huh. Cold, Texas. The wide bay is coming together, though. That looks really nice. Look at the size of that frickin' thing. It's already as tall as the starships. Look at SN15 and 16 on the left. No, it's not climate change, Solar. It's ligma change. Oh, okay. Yeah. No, I'm not finishing the joke. You already know the end of the joke. We need to worry about ligma change, and the proof is in the pudding. God damn it. Ligma pudding. Come on now. Come on now. Come on now. What the hell's wrong with me? Okay. These are trucks. They have wheels. No, these trucks are carrying elevator parts. This is an external elevator that most likely is going to find its way into the wide bay. Hey, Snake, what's going on? Nice picture from this morning, bud. Very good there, guy. What the heck? You can't just say Ligma pudding when I'm trying to work. It's pretty funny, actually. Trucks with wheels. Did the thing launch? The thing's launched. Falcon 9 launched today, and then Launcher 1 launched as well. Good insertion, good deployment of all payloads across the board. And a very tired EJ. Jurassic pudding. Wait, what? Yeah, the footage from the stream, Snake. If you haven't watched that, go watch that. Go watch that. Those are the mass simulator ropes. Oh, single wide. Oh, nope, it's a double wide. Hell yeah, brother. That's the nose cone section of ship 21. It's still in pieces. High bay has booster 7 inside of it. That's the midsection. So you're looking at the top of the liquid oxygen tank, bottom of the liquid methane tank, right where all those stringers are. And there's still a super heavy thrust plate there on the left that's on the diagonal. And then this is a forward dome from a super heavy booster as well. That thing's been sitting there for a couple of days. Dodge. Did you see that the title showed a seam with the nose cone? No, Hilness, but we'll go back and look in a second. Speaking of Ligma, so SpaceX did a huge mass simulator test with those inflatable mass simulators that you inflate with. That well, you don't inflate them. You fill them with water, and when they're filled with water, they look curious. They basically picked up about 300 tons with the chopsticks, moved them around, moved them back down, and kind of just let them sit there for a little while. Those bags right there are the 50-ton bags. So they're filled with water. See the hose at the bottom? They fill them up with water. And the two 50-ton bags on each chopstick is still full. You were right. It is cold, right? Yeah. So... see, that's a 50 ton water. That holds 50 tons of water. Or what would 50 tons be? 50,000 liters, right? And then these hold 100,000 liters. So these are 200-ton bags, and that's a 50-ton bag. And that's a 50-tonner, and then there's two deflated 100-ton bags right there. Like I said, there's a hose that just hooks up to the bottom, and they fill them up with water. The chopsticks yesterday lifted 300 tons worth of water up and around, which is pretty good, and they barely even bent, which is bodes really well for it being able to lift up super heavy. That's why they're testing it. They're testing it with water first to make sure that they can lift these things up. About a full 747 of weights. Yeah, see, there's water leaking out of the balls. What is the dry mass on super heavy supposed to be? I'm not 100% sure. I've theorized, we kind of were thinking that if they're lifting like 300 tons with this thing, and the maximum would be 500 tons, 200 tons and a 50 ton on each chopstick, so that's 500 tons total. There's probably a factor of safety in there somehow. So I don't know. Based off of that and kind of what we know about Raptors, I would guess that super heavy somewhere in the ballpark of 200 tons. That's just a guess, though. 200 tons is 440,000 pounds. So it is heavy. Dry mass. Yeah, yes, dry mass. It's got 33 rocket engines on it, dude. Oh, wet mass like 1,000 tons or something. Yeah. Wet mass, the chopsticks couldn't lift it. No way. Hey, Judo, 53-month resub. Oh, you doing me, old sunshine? Damn, that's some huge balls. Yeah, there's some terribly huge balls there, innit? Big orange bullocks. Hard to comprehend scale on that thing. Yeah, I know, right? Those bags are huge. No, you don't, Juno. No, you don't. Look at it. They're bigger than that bulldozer. I mean, mass simulators or speed bags for a giant person. No, I'm pretty sure that's a crane test water bag. That's 100 tons. I'm pretty sure. You can tell because of the way it is. There's another truck offloading nitrogen right there. Speed bags are fun, dude. I want to see the chopsticks bench pressing a 747. I'm fairly confident they could probably lift one up, yeah. What material are the bags made out of to hold so much weight? Newbie, if I had to guess, well, let's take a look. Rubber, maybe vinyl or something. It's stitched, whatever it is, so this is like a dinghy. Quit playing with your dinghy, chat. Scroat can relate to these bags. That's horrible. Neat. Take-Two is hiring senior quality assurance for KSP2. Oh, yeah? Fire hose canvas and rubber? Yeah, that sounds about right. Hillness, we should apply. Let's do it. I guarantee you they'd look at my application and be like, oh no, not this guy. Balls made out of dinghies. Yep. Yep. Oh, okay, phone sister. Right on. So, special high-strength coated PVC TPU fabrics such as polyester, nylon, and Kevlar. I was going to say Kevlar, but I didn't want to guess. It looks like rubber, but yeah, who knows? The game would never leave alpha. You shut your fat mouth. Yeah, that's the remains of Booster 3. Yeah, there's the simulator test. That's a lot of weight. Alright, alright, alright. Alright. Okay, fine. Oh, don't drop the guitar.
Go and throttle up.
They did more ball testing this morning. Please don't call it that. Please call it mass simulator testing. Please, Core. For the love of God. Don't call it ball testing. God damn it, man. That's the name that sticks, isn't it? That's gotta be the name that sticks. Yep. Oh. So they did more mass simulator testing this morning. God damn it. It's a very important test. Yeah, Mechazilla's going through puberty. Oh, somebody already made that joke. Damn it. Big Star, you stole my joke. So once again, they're testing the chopsticks ability to be able to lift super heavy up. Once they complete testing with the mass simulators, I'm pretty sure they'll probably try to lift Booster 4 up off the ground. Okay. Did we get it out of our system until... let me rephrase that. Did we get it out of our system until tomorrow's space news? Balls. There. I'm done. All right, cool. Yeah, that's true, Illness. Yep. Is that possible? All I'm asking for is a 24-hour referendum on ball jokes. Next road closure is scheduled for January 18th. All right, cool. That's next Tuesday. All right, cool. Is it out of our system? You asked too much from us? Mole, 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 mole. Dread. From the U.S. Commander. Nuts. Yeah, right? Well, EJ, the ball's in your court on that referendum. I want to die. You know the meme of the guy that's sitting at the computer with the I want to blow my brains out face, like the